Hello everyone, am I audible? Okay, so fine everyone, I think I'm audible to every one of you. Yeah, so good afternoon and let's start the class. Last class 28 October we have studied with topic. Okay, fine. I don't know, so nice to meet you again after many of the years. Okay, fine, that's great. Okay, good afternoon everyone. So let's start with the class. Yeah. So I believe in last class I was talking about PCA, right? PCA and what is PCA and what is a single value decomposition, what is the eigenvector, what is the eigenvalues, and let's suppose if I have 100 columns given to me, so how I will be able to bring down those 100 columns maybe into 3 columns, or maybe into 4 columns, maybe into 2 columns, or maybe into n minus 1 column, right, with the help of PCAs. So we have seen those things, right? So now I'm going to extend the same lecture, and we are going to see uh, more and more things in terms of PCA itself. So let me just open up my notebook and we will start. Okay, so this is the same notebook I think we have executed, and we were trying to decompose a data set into its lower value. Now okay, so maybe we can try to take another data set today, and we can try to do this single value decomposition. We can try to perform this PCA operation on top of those data set, and we will try to understand whether we are able to perform these kind of operations or not, right? So let me just try to take some sort of a data set over here, and let me do all the necessary imports. And this is the same notebook that we have discussed in yesterday's class, sorry, in our previous classes. And yeah, so we can try to use the same notebook. So just be ready. So I'm ready, guys. Everyone got another offer from product based companies. Okay, that is amazing, Subham. Congratulations. I got offer letter from Ahinon as a junior data scientist. Thank you so much for giving me offer, sir. Divanjan Chaudhary. Okay, that's great, Divanjan. So yeah, let's have a discussion in office then. So I will be available in office by Monday. So today I'm working from home, as it's my class day basically. I'm facing a problem in keeping everything in mind. How should I practice? Don't worry. So I'll give you some tips at the end of this class. Let's have a discussion, and I think we can talk on that. This notebook is not uploaded. Yeah. So this notebook is not uploaded. I'm aware about it. So this will be uploaded once I'll complete. Okay. Yeah. Recordings are already uploaded, by the way. The discussion that we have done. So I believe this is already available. Now, let me open up a codeshare.io as well, so that those who are facing an issue with respect to copying all those information, so I think you can copy it. So just try to open up codeshare.io, guys, and try to hit this link. So I'll try to share each and everything over here. So try to hit this link. It's a small O Q capital L E M and like a capital M, right? So whatever code that I have, so I'll try to share over there. Okay, and as far as this data set is concerned, so let me share a drive link. Anyhow, data set is already available inside your dashboard from the previous lecture. If you will try to find out the PCA, so I'm going to use the same data set. I'm not going to use a new data set over here. So someone is saying that no voice is coming. So guys, are you able to hear me? Yes. Okay. Able to hear. Thank you. PCA. Okay. So fine guys, in your codeshare.io, I'm going to share this drive link. So this drive link is given to you. So please try to copy this drive link, and I'm pinging you a drive link even inside your chat box. So now drive link is available even inside the chat box. Again, Vincent, it's not my issue. So everyone is able to hear me. So I think it's your system issue. So please try to check your system. It's not an issue from my end. And those who are typing unnecessary things into codeshare.io, so it will be better if you can stop and don't do it. Okay. So CAN and PCA, where is PCA? Okay. So fine. We can try to import maybe pandas as PD, and then we can try to import numpy as NP over here, then import maybe matplotlib dot pyplot as maybe a PLT, and we can make it this things as a inline matplotlib inline. Okay, so these are the imports that you have to do. So just do this kind of an import, yes, and then once this import is done, so I believe we can start working with the PCA part. So here, once you will end up doing this import, so what we are supposed to do is, I have already given you a dataset link. Hope you all are able to copy the dataset link and you will be able to download it, right? So once you are able to download this dataset, so just to do one thing, pandas dot read CSV, nothing else. Simple dataset read operation, and it's a glass dataset that I have shared with you. So just try to import this glass dataset. So glass dot dataset you are supposed to import. So this is the dataset that we have, and here you will be able to find out a multiple like a columns RINAMG, ALSIK. So these are nothing but just an element. So element from the periodic table, I believe. And here, so based on all of these composition, so classes is given to you. So whether class is equal to 1, class is equal to 2, class is equal to 3, and so on, right? So this is basically a glass data set, which is again an open source data set, which I have considered. But here, so we are not trying to solve any kind of a classification problem. So what we are trying to solve is, we are trying to solve a decomposition problem. So we have so many columns over here, which is available to me. So what I want over here is that decompose it. So maybe these many number of columns are not required. If we can try to project the similar number of columns, maybe into a lower space, that will be better. That will be way better as compared to representing this data set in its current state. So here what we can do is, so maybe we can try to take this data set as a data, and then we can try to maybe perform, or we can try to check so whether data set is having some sort of a null values or not. So data dot we can try to check is NA, and then we can try to check summation of it. So we'll get to know whether there is a null values or not. So yes, in this data set, there is no null values which is available, right? So in each and every column, null values is equal to a 0. This is what we are able to understand. Fine. So once we have made sure that, okay, fine, there is no null values which is available over here. So I think we are good to move. If there is a null values, in that case, you are supposed to call up imputation in general, right? So you will have to do an imputation from here. So once I do not have this kind of null values, right? So maybe we can try to select all the feature column, because whenever we talk about a decomposition of the data, right? So maybe a dimensionality reduction of the data set. So in that case, we are supposed to consider only a feature column. Now, if I'll show you my data set, right? So what are the feature column? So can I say that these are the feature column? Yes. So these are the feature column that we have. So if these are the feature column that we have, so what we can do is, so maybe we can try to select this feature column, and then we can try to apply a PCA on top of the same thing. Yes. So yeah, we have done the import of all the libraries. we are trying to load the data set, and then we are trying to check whether there is a null values or not. If there is a null value, in that case, I can go ahead with the imputation column wise. Now, so if all those things are done, and let's suppose if I have to decompose this entire data set into a lower space. So what I will do is, so maybe I can try to select just a feature column. I'm not going to select a label column. Label column will be as it is. We are trying to work on the decomposition part, and it's always applicable only on top of your feature column, not on your label column. So fine, I can try to just select all those like a feature column. So maybe I can try to call data is equal to data dot maybe drop, and what kind of things we are going to drop. So maybe we can try to drop basically these index column we can try to drop, and then class column we can try to drop, because index column is an unnecessary column for me, right? It's not a significant column in terms of forming any sort of a relationship. And class columns are nothing but it's just a label column which is having a classes 1 to 7. So here we don't require this particular class column. So fine, what I can do is, so maybe I can try to write over here like a index column. So just drop index column index, and then we can try to drop a class column class class column. And here we can try to write axis is equals to 1, right? So here this is the data set I will end up forming. So these are the data set which is having just a feature. So it is not having any kind of a labels at all. And maybe on this data set, we can try to implement some sort of a like a PCA or some sort of a dimensionality reduction, single value decomposition, we can try to implement on top of this one. Now here, so what is the very first rule which we are supposed to follow in case of a PCA? So any idea, guys? So someone is asking me that isn't PCA used in unsupervised learning only? No, just try to go through my previous classes. I think you have missed my previous lecture as well as my recording lecture, right? So I have never mentioned that you should use PCA for supervised or unsupervised. I clearly mentioned that it's been used for anything and everything. So wherever we have to decompose a data set. So I believe you have missed that lecture. I think you should go through that one. Okay. Now here, so we already we have seen and we have studied that, okay, so whenever we are trying to talk about the decomposition of the data set, so we are supposed to first of all check so whether mean is equal to 0 and standard deviation is equals to 1 or not. This is the base rule, right, that we are supposed to apply whenever you are trying to do a decomposition. Because if you remember, I have shown you a picture, I have shown you all the dots. So where you are trying to shift a data set, first of all, where mean is equal to 0 and standard deviation is equals to 1. And ideally, this is called as standard scalar, because standard scalar does the same thing, right? Standard scalar does the same thing. And here, so if you will try to find out basically a mean and standard deviation of this data set, it's not 0, right? How I will be able to find out standard deviation and mean of the data set, by the way? So can I say that data frame dot DESCRIBE, and I can get to know? Yes, DESCRIBE. Okay. So sorry, it's a data, right? Yeah. So here mean is not equal to 0 and my standard deviation is not equal to 1. Clearly visible to me, right? So if mean is not equal to 0 and standard deviation is not equal to 1, in that case, I'm supposed to extract. In that case, I'm supposed to convert this data set where data set must be having mean is equal to 0 and standard deviation is equals to 1. So fine, if I have to do so, so in that case, maybe I can try to import standard scalar. So from sklearn, maybe I can try to import. So from sklearn data pre-processing, so we can try to import basically a standard scalar, right? So standard scalar we can try to import, and then we can try to make an object of it. So a standard scalar, and here, so we can try to call scalar dot fit transform, and maybe here I can try to pass out my data set, right? So here I'm going to pass my data set. Now, so once this will be done, and then if I'm going to check what is a mean and what is a standard deviation of the data set, it will be equal to 0 and it will be equal to 1. So mean will be equal to 0. It will be closer to 0 for sure. And it will be closer to 1 in terms of a standard deviation. So fine, things are handled over here and we are not supposed to worry about it. It's completely fine. Now, let's suppose this is going to give you a NumPy array. Maybe if I have to convert this entire data set again into a data frame format, what we can do is, so maybe we can try to call pandas.data frame, right? Pandas.data frame, and then we can try to pass maybe this particular data set. So let me store this data set somewhere. So scale underscore data, in which I can try to store it, and we can try to pass this one. So a scale underscore data, and column wise we can try to give a same column name. So data dot columns, right? So here is a data set that I'm able to build again. Maybe I can try to store these things into a data frame. So here is a data set or data frame I'm able to build. Now, if you will try to check data frame dot BESCRIB just for the getting some sort of a surety, you will be able to find out standard deviation is equals to 1 and your mean is equals to 0, e to the power minus 14, e to the power minus 15. So it's a very like a less number. It's very closer to a 0 that you will be able to find out. So yes, our objective is achieved. We are able to find out, or we are able to build a data set. So where mean is equal to 0 and standard deviation is equals to 1, which fulfills a first rule of a principal component analysis, right? This is what we have discussed, right? So for the PCA, now what is the next step, guys? What we are supposed to do? So let's suppose I'm looking for maybe converting this entire data set into a lower label, or maybe into a very like a few number of columns, maybe 2 or 3 or 4 PCAs in which I would like to convert this data. So what is the next step? This one is done, right? We are not worried about it. That's completely fine. Now, what is the next step that we are supposed to do? So can I say that we may try to find out the covariance matrices? Yes. So second thing is we can try to find out the covariance matrices. Once I will be able to find out covariance matrices, right? Then what is next? So then we are supposed to find out the eigenvector and eigenvalue, right? So once I will be able to find out eigenvector and eigenvalues, so whichever is having the highest eigenvalue, so we are supposed to take that eigenvector, right? And we are supposed to do a matrix multiplication with the existing data set. In this way, it will be able to generate what? A PC1, a first principal component it will be able to generate. Then if I have to generate a second PC, in that case, what I will do? So I will try to take the second highest eigenvalue, right? And its respective eigenvector. So that eigenvector I will try to multiply again with a data set, right? A whole data set, matrix multiplication of the whole data set. Then what I will be able to do? So then I will be able to get a second PCA, third PCA. So how many PC I will be able to generate, by the way, over here? Yes. So can I say that we can try to generate even n number of PC? But yeah, there is no meaning of generating again n number of columns, right? So again, n number of columns, because we are looking for, and again, all those n number of columns are not going to give you equal significance, right? So let's suppose I'm looking for a data set which retains a 90% property of the original data set. If I have to build a data set, if I have to form a data set, so where a new data set which I'm trying to derive out of this data set with the help of a PCA, right? So if that should contain a 90% property of the data set, right? So in that case, what I'm supposed to do? How I will I will be able to assure that, okay, these main number of PCAs are going to derive a 90% relationship of my data set, 95% relationship of my data set, or 99% relationship of my data set. So with the help of explained variance ratio, I think this is what we have discussed. So based out of the explained variance ratio, we can try to do a screen plot. Yes, right? So based on maybe explained variance ratio, so I can try to draw the screen plot and my work will be done. So most of you, I can see in a chat that you all are able to remember whatever we have discussed. And in this way, manually, I will be able to find out a PCA, right? Okay. So what we can do is we can try to use even a library over here, a PC library, which does the same thing. So maybe we can try to do a same thing, right? We can try to find these things manually, and we can try to find out these things with the help of libraries as well, in both the way, right? In both the way, so we will be able to perform these things, and we can try to match. So whatever result is given by library and whatever result we are getting from our manual calculation, so both of these calculations are same or not, so that we will be in sync, right? That whatever work library is doing, so we are able to do a same thing without using a libraries or not, because it's pretty much possible. Just a calculation which library is doing, I can do a calculation even by myself, so without using a library. So either way, that's completely fine. So guys, just do it without using a library. I have shown you steps last time, and now I'm trying to write a code with library, so we both will discuss both the code. So here, from sklearn I can try to import. So yeah, from sklearn I can try to call decomposition. So decomposition, and we can try to import PCA out of this one. Fine, this import is done. I can try to create an object of a PCA, right? So that I will be able to pass a data set over here. So here is an object of a PCA which I'm trying to create, and then I can try to call PCA dot fit a transform, right? So PCA dot fit transform I can try to call, and maybe I can try to provide this data frame. This is the data frame that we have created, right? So maybe we can try to pass this particular data frame over here. Okay, so this part is done. Now, once I will be able to dump this data into this PCA algorithm, now what happens? So fit the model X with the applied dimensional reduction on X. Now here, so if you will try to check, so again, it's trying to create a new X for you. New X it is going to create for all of you. Now here, if you will try to check the dimension of the data set. Now, what is the dimension of this data set, by the way? What is the dimension it has created? No, it's 2D, that is fine. But what is the dimension, like m cross m I'm talking about? So can I say that it's a row cross number of columns, right? Because by default, unless and until you are not going to define that how many PCAs you are looking for, here is a component, number of components. So what we have done, have we provided a number of component? No, right? Number of components simply means that a number of the PCAs that we are expecting, right? Number of component to keep. So we have not provided any kind of a number of components. So by default, it will be able to take 9 columns as a number of component, and it will try to generate a 9 PCAs in general, right? So this is what it is going to do, right? And this is what it is going to generate. So it has already decomposed. So the first one is a PC1, then second one is a PC2, then PC3, PC4, and so on. It has created, or it has generated. Let's suppose I'm going to convert this data maybe into a data frame. So we can do that. There is no issue, right? So pandas dot and then data frame, and simple, just try to pass this data inside this one. Yes. So can we say that we are able to generate a 9 columns? Yes, we are able to generate a 9 columns because we have not provided a number of component. If I'm going to provide that, okay, so like a number of component is equals to like a 2, 3, 4, 5. So in that case, it will just keep that many number of the component. But when we have not provided, so it will try to generate a PC0 to PC8 or PC1 to the number of columns. Because I was not sure that in how many columns or by using how many PCs I will be able to explain my whole data set. I was just confused, right? I don't know whether one column is required, just PC1 is required, PC2 is required, PC4 is required, PC 8 is required. I don't know about it. Yes. So what I have done, I have just generated a PCA for all the columns. But am I able to solve a complexity problem over here by generating 9 PCA? I don't think so, right? The problem remains the same, right? Although we are able to generate all the PCAs, but I'm not able to solve that particular problem, the original problem which we were trying to solve, right? So how I will be able to do that? So how I will get to know like how many columns we are supposed to keep? Yeah. So can I say that now we are supposed to go ahead with the explained variance ratio and the screen plot? Only in that case, I will be able to make sure that, okay, So how many columns we are supposed to keep just by looking into that particular graph. So fine, no issue. We will try to do that, and we will try to find out. Our next step is to find out how many columns actually we are supposed to keep, how many PCs we are supposed to keep, right? So that I will be able to derive a meaning of whole data. I will not end up losing a data set in that particular way. Okay, so maybe we can try to call a plt.figure plot figure, right? And then we can try to call plt.plot over here, numpy dot come sum we can try to call cumulative sum over here, and PCA dot explained variance ratio. So here, whenever you are going to build a model, you will be able to find out explained variance ratio. So PCA dot explained variance ratio, you will be able to find out. Now, what is the meaning of explained variance ratio? Yeah. So I think we all remember and we all are able to understand what is the original meaning of a explained variance ratio. So it's nothing but it always tells you that whenever you are trying to decompose a data set, so a particular decomposition is going to give you, or particular PCs is going to give you what kind of a significance. And this is nothing but distance of the data point to a particular PCA component divided by a distance of everyone. This is what we have discussed, right, in terms of a explained variance ratio, and even we have done the calculation part manually. So fine, this is something that we are going to print it with the help of this program. We are trying to print it, and this is something that we have in our hand. And then what we are supposed to do, so explained variance ratio we are able to get. Yes. Now the second thing is explained variance ratio is fine. And can I say that this is the explained variance ratio for all the PCs that we are able to see? Yeah, this is the explained variance ratio for all the PCs that we have. Yes. So fine, no issue. So number of column versus explained variance ratio, I'll try to plot. Yes. So here plt.plot this one, and then we can try to call what? So we can try to call maybe like a plt.show over here, right? Now, this is a graph that we are able to get. Where on x-axis, we have what? So in x-axis, we have a column, number of column, and on y-axis, we have what? Explained variance ratio. A very simple thing. Maybe I can try to label it if it is required. So plt.x label. So plt.x label. So here you have a number of column, 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 and then like a plt.y label, and here what you have. So here we have EVR, let's suppose, right? So here you have EVR. So fine, this is a number of column versus explained variance ratio. Now here, just tell me one thing. How many VC component I'm supposed to keep so that I will be able to explain all the data set? Yes. So I think most of you will be able to give me an answer just by looking into this one, that how many PCs or how many columns we are supposed to keep. I believe if we are going to keep maybe a 6 column, right? If we are going to keep a 6 column, so maybe I will be able to explain 99% of this entire things. Maybe if I'm going to keep 5 a column, so in that case, approximately 95% of the data I will be able to derive. If I'm going to keep maybe a 4 column, right? So in that case, 90% relations of the data set I will be able to keep. It says that if I'm going to keep a 3 column, so in that case, I will be able to retain 80% of the relation. So above 90 is fine, right? Above 90, if we are able to keep a relations of the data set, even after doing a decomposition, so maybe we are good, right? So maybe I can try to pick and choose 4, then 5, and then 6. We can try to test it with our algorithms, right? So whether we are able to train it or not. So these are the ratios, or this is how we are able to do a screen plot, right? And after doing a screen plot, so yes, we are able to perform these kind of operations in a easiest possible way. Number of component may be 4. So if I'm keeping 4, in that case, 80% of relations my data set will be able to derive, right? Okay. So 80% of the relations my data set is going to derive. So now what we will do is, again, we can try to create a PCA. Yes. And then n component is equals to 5 or 4, whatever I want, I can just try to keep it. Yes. Otherwise, we have already generated a principal component. We can try to select this one. Even that's fine, right? Or else, if I'm aware about a number of components, it's in that case, whenever I'm trying to create an object. So let's suppose a PCA1 we are trying to create. Last time we have created PCA. So number of component is equal to 5, and then PCA1 dot, so PCA1 dot fit, I can try to call fit transform. I can try to provide a data set, and I have already mentioned that it is going to be like a 5 component. This is what I'm looking for, right? So maybe a new data set I can try to create in this way. Now, so what is this new data set? New underscore data. So this is the new data set that I'm able to receive. That's amazing, and that's pretty much good, right? Maybe I can try to convert this entire data set into a data frame. So here I can try to provide a new data set, and then here is my data frame. If I would like to name these things, so maybe I can try to name these things columns wise. So it's not a same column because now it has decomposed. So maybe PC1 I can try to name. So PC1 over here, and then like PC2 I can try to name. Okay, so here is a name which I have given to this one, PC1, 2, 3, 4, 5, 6, and 7, 8, and so on. This is something that we have done. Okay, so this is the final data set that we are able to receive, and original data set with which you will try to compare. So original data set was having a 9 column. Now we have a 5 column, and with the help of this 5 column itself, we are able to derive a 90% plus relations over here. And yes, in this way, we will be able to decrease our complexity as well. So instead of training ahead with the 9 column, right, finding out a relationship with the 9 column, so we will try to find out a relationship with only this 4 column. Now let's suppose if I have to build a classification problem, if I have to build this classification things, right, as per my data set, if I have to build a classifier, no issue. So this will be your feature, and y will be your label. Do the classification, and after doing the classification, we are good, right? We are good. So whenever a new data will come, so what you are supposed to do is you are supposed to save this model. The same model that you have used, you are supposed to save this model as well, this PCA one object as well, because whenever there will be a new data set, right, you are supposed to pass those new data sets so that it will be decomposed. So once it will be like a decomposed, then only you will be able to pass those data set into a next algorithm for the prediction. Otherwise, you will not be able to pass those data set into a prediction. So just to make sure. So this is the pipeline that we are trying to build, let's suppose. So we are trying to do a principal value decomposition first of all, and then we are trying to implement our classifications on top of that. So what you are supposed to do is, whenever you are trying to do a prediction with respect to a new data set, you are supposed to perform a similar kind of a approach. You are supposed to do the same kind of a things. Maybe we can try to take one example of it, right? So I believe we have discussed a decision tree, right? And we have used a decision tree maybe for the classification problem. Yes. And even in this a data set, so we have a multiple classes. Yes. So let's try to do one thing. So maybe we can try to build one classifier over here, and then we can try to test it. So this is the decomposed data that we have. So this is the decomposed data that we have. And now if I'll try to recall the original data set, so this is the original data set. Maybe I can try to store these things into data one. So here data one dot Y, I believe Y is a column name. Okay, so let me just check what is the column. It's okay, class. Fine. So can I say that this is going to be my Y column? Yes. And can I say that this is going to be my X column, right? So let's suppose this is my X and this is my Y. So my X is ready, okay, after doing a principal value decomposition, and my Y is ready, right, after this one. Now what I can do is, so maybe I can try to call some sort of a classifier, and then I can try to pass all of these data inside that classifier just to build the classification algorithm over here. So no issue, we can try to call maybe a decision tree. So sklearn dot tree and then import, right, decision tree classifier. Fine. So, and again, so if I have to plot my tree, so maybe I can try to import a tree in that case. Yeah. Now here, what I can do is, so maybe I can try to like directly pass these data set, this entire data set into a decision tree classifier, and then I will be able to build a entire model. There is a chances. So fine, no issue. So dt underscore model. So classifier I'm trying to build. Maybe I can try to call a decision tree classifier, the object that I have created over here. So this is an object, and then so dt underscore model dot fit. So what I'm going to pass, can I say I can pass X and Y over here? Yes. Okay. So we can try to pass X and Y in this particular place, right? Okay. So once we are going to pass X and Y over here and execute, it is able to build the model. That is completely fine. We are able to build the model. Okay. Now, let's suppose I have built the model. Fine. And what is the original shape of my data? So original shape of my data set is this one. Yes. So what user will provide? So can I say that user is basically a unknown person. They are not aware about that what you have done internally, whether you have implemented a PCA or whether you have not implemented a PCA. User is not supposed to aware about it, right? So user is a completely like a person who don't understand this data science part or this PCA or whatever we are trying to build over here in terms of a model, right? So basically user is not even like aware about all of those things. So if user is a complete unknown person, so let's suppose if user is trying to do a classification, what user will do? So can I say that user will try to provide all of these columns? Yes, user is going to provide all of these columns over here. Now if user is going to provide all of these columns, is it going to work, your classifier? No, right? So if user is like going to provide all of this, it is not going to work at all. But yes, user will provide the original form of the data set. It's not like user is going to provide like a 5 column because he is aware about that. Okay, fine. So PCA you have created and that is having a 5 component. User is not even aware about it. So what next that we are supposed to do over here? So if that is a case, in that case, you are supposed to like we already have this PCA, right? So we already have that PCA object that we have created, which was responsible for decomposing my data set into a 5 component, right? So in that case, we can try to pass this data. So I believe PCA1 is an object that we have created, right? So PCA1 is an object that we have created. So maybe we can try to pass this data set inside a PCA1. So if I'm going to provide this data set inside a PCA1, so let's suppose if I'm going to provide this data set inside a PCA1, what will happen? Okay. Now what is going to happen? Yes. So here PCA, and then you will be able to find out something like a transform method. And here is a component. So can I say that I'm able to generate a 5 component of this data set automatically? Yes, we are able to generate a 5 component of this data set automatically, right? And then can I say that whenever we are going to do a DT model dot predict, right? So we are supposed to provide this data set and what is a class that we are able to receive. So can I say that we are able to get some sort of a prediction? Yes. So this is a pipeline that you are supposed to follow, the same pipeline that you have used at the time of training. Now remember one more thing. We have used even a standard scaler, right? We have used even a standard scaler. So are we using a standard scaler over here? No. So you are supposed to actually use a standard scaler as well before even sending a data set to a PCA. So here what you are supposed to do is, so you can try to call a scalar. I think this is the object that we have created, a same object, not a new object, right? So what is our scalar object? So this is the object that we had created. So we can try to use this scalar dot transform, and then we can try to keep our data set inside this one. Where is an issue? So scalar transform, there is some issue with column indentation 1, 2, 3. So yeah. So now can I say that my output is correct? Last time it was giving me class is equals to 5 because I had made a mistake. I have not done a standard scalar because with my original data set, what I had done at the time of training, first of all, I have converted my data set by using a standard scalar. I have just standardized my data set. Then I have used PCA. Then I have created the model, a classifier model, right? Now, so last time it was giving me classes is equals to 5, which was incorrect class, right? Can I say that this time for this data set is giving me a correct classes? Yes, everyone. Yeah. So are you able to understand a training pipeline as well as prediction pipeline? So whatever we have used at the time of a training, right? Similar things we are supposed to use even at the time of a testing or even at the time of a doing some sort of a prediction. Exact same thing we are supposed to use. Nothing else. We are supposed to use at any point of a time. So hope this one is making sense to all of you. So how we are using a prediction? Okay, fine. So fine, I think we are good, right? So we are good with each and everything that we already have over here. Yeah. So only about a PCA one, the transform. Can you give can you move a notebook up? Yeah. So what if there are multiple categorical columns there into a data set? You can try to, based on the categorical nature of the data, so you can try to do a transformations and then you can try to use it. Can we store a pipeline as a pickle file? You can store this scalar, standard scalar as a pickle, and then PCA as a pickle, and then again this one, decision tree as a pickle. So every object you can try to store, just an object, right? So you can try to convert these things by using any of such methods, and then you will be able to store it. Simple. Okay. So now this one is done. And happily we are able to perform these kind of a operation. So any one of you are able to do some sort of a manual calculation? Anyone? Okay, so fine, now moving ahead, right? So PCA part, So in the similar way, so the way we have done manual calculation last time, so I believe you can try to do a manual calculation even in your system, and you will be able to get the exact same result. So generally we don't do a manual calculation, but I have shown you so that even without using an algorithm, this classes, by the way, so this PCA classes, you will be able to do it, which is pretty much possible because we know the internal mechanism of this entire thing. So this is pretty much possible, and we all can do it in a easiest possible way. Okay. So Devanjan has done these things. Okay, that's great. And X and number. So fine. This is a manual calculation, right? So he has converted everything into just as a function, and just call one function and your work is done. So, okay, amazing, Devanjan. That's great. Yeah. How we can see a whole data and remove the dots in between? Which data set you are talking about? Okay. So now all of you can use same thing if you want. Okay, now moving ahead. So let's try to understand maybe something different. So last time we talked about a PCA, and we have not done any kind of a implementation for this this one, right? For your clustering algorithm. Yeah. Okay. So fine. Let's try to understand maybe implementation of clustering algorithm. So let's see how it works, and we can try to make use of even a PCA over there, and then we can try to build a clustering model, right? So first algorithm that we have discussed was a k-mean algorithm. So this was the very first algorithm that we have seen. And yes, so maybe we can try to understand this clustering algorithm. We can try to do a implementation of k-mean HC clustering, as well as we can try to use a DBSCAN. So again, over here, if I have to perform a clustering operation, so maybe we can try to use a different kind of data set, or maybe models. We can try to just group the data set. So let me just try to share one data set with all of you. We all can use that data set. It is, if possible, can you please explain the manual calculation? So just look into my previous classes. I have already done that manual calculation. Okay, so I'm just going to ping you a link. So just try to download this data set, all of you. Okay, and maybe we can try to use a new notebook over here. So fine. Okay, so I've already pinged you a link, and I believe you are able to copy this particular link, right? So it's already available in code share as well as it's available inside your chat box. So just try to copy the link and yeah, leave it. So this is the data set that we have. Let's suppose we have a data frame over here. So we have like so many different columns: customer ID, genre, we have a age, we have a annual income, and we have a spending score. So these are the different features which is given to us. Now let's suppose if we have to like see, or maybe let's suppose if I'm looking for maybe a kind of a grouping of the data set, because let's suppose if I would like to like offer some sort of a discount, or maybe some sort of like a new things, or maybe some sort of a card, or maybe some sort of a gift voucher to all of these customers. So maybe yes, I can try to give them based on their age, based on their annual income, based on their spending score, based on their gender. So based on all of these things, so we can try to provide them a different kind of a offer, discount, or credit card, if that is a problem with me, right? So I can try to provide them a different kind of a offers, and we can try to provide a different kind of a discount. So let's suppose we can try to consider maybe an annual income spending score. Based on that, I would like to offer a credit card. If your annual income is this much, and if your spending score is this much, so let's try to take this particular credit card, or let's try to take this one from my side. If this is the case which we are supposed to if this is the case that we are supposed to utilize. Okay, so here, first of all, I'm supposed to select maybe this annual income column and this spending score column. So here is a data frame and dot, right? So data frame dot, maybe we can try to call iLock over here and try to select all the rows and column wise, start from the column 3 and go till the last. So this is the annual income and this is the spending score. Let's suppose this is my X values, X data set. And here, so as we are talking about a clustering, so in case of clustering, it's an unsupervised approach. So for sure, we don't even need a label Y. Okay. So this is a data set that let's suppose we have created. Now my main problem is I'm trying to implement a k-mean algorithm with respect to this data set. And how many clusters I'm supposed to create, I'm not aware about it, right? So how many clusters I'm supposed to create, I'm not even aware about it. So what we are supposed to do? Yes, anyone? Let's suppose I'm trying to build a group of this data set, right? But I don't know how many clusters or how many groups I will be able to form. Okay, so what we can do? So maybe we can try to call from sklearn, right? Dot cluster, right? And we can try to import k means over here. Okay, fine. So from sklearn.cluster, we can try to form a k-mean over here. And WCSS, we can try to create maybe a simple blank list. So we can try to find out what is a WCSS and then what is basically a number of the clusters. And we can try to plot it. And we can try to plot an elbow plot. And out of the elbow plot, maybe I'll get to know. So what is the total number of the clusters that I will be able to create? Yes. So first of all, I'm supposed to find out the value of k over here. No issue. So we can try to call for I in range of, maybe I'm trying to like test these things till a 20 cluster, right? So till 20 cluster we are going to test, or maybe till 15 cluster if I would like to test. Then okay, fine. So how many clusters it is going to form? Let's try to test it. So which maybe k mean is equal to an object of a k mean we can try to provide, and number of clusters, so it is going to test it for like a I. So for one cluster, for two cluster, for three cluster, and so on, it will keep on testing it. Init is equals to, so here if you will try to find out, right? So here if you try to find out, so by default what it is using k-mean plus plus algorithm, right? So it's completely fine. We are going to use k-mean plus plus, right? So not a k-mean, because k-mean plus plus is a better version of a k-mean, right? randomization of the data set. So maybe we can try to keep as a 30 or whatever number you want, right? And then k mean dot fit I can try to call, and I can try to pass x data set over here, x data set over here, and then we can try to call maybe once after fitting this data set, we can try to find WCSS, or we can try to find a inertia of the data set. So WCSS dot append, we can keep on appending it, and k mean, inertia of k mean, we can try to append it inside this one. So inertia of k mean, inertia, INERTIA, inertia of k mean, we can try to append. Okay. So inertia, I think we have already discussed. Inertia is nothing but your within cluster summation of a square. So this is something that we can keep on appending. Now, if I'll try to check my WCSS list, this is the list that I have created for all the 15 cluster. This is the WCSS for me. I can try to plot it. So maybe I can try to call plot PLT dot maybe a plot over here, and then for range is equals to 1 to 15, right? 15 data set we have, or maybe you can try to give a size over here versus WCSS. Now this is a plot. Now tell me how many cluster I will be able to form out of this like a plot. So this is called as elbow method. Inertia slashes that makes use of elbow graph. Yeah, so inertia and WCSS is same, just terms are different, that's it, but technically it's same. So can I say that maybe I can try to create a 5 cluster over here? Yes. Can I say that maybe I will be able to create, because after that it's kind of a smooth. So 5 to 6 cluster is fine. So value of k should be 5 to 6, either 5 or 6. You can try to use it, and maybe you can try to even test it, right? Okay, no issue. So I can try to, now I got to know that, okay, fine. So number of k is equals to 5, right? So fine, I can try to call a k mean over here, and then I can try to provide number of cluster is equals to 5. And yes, by default it will be k mean plus plus INIT is equals to k hyphen means plus plus random underscore state is equals to maybe 30. I can try to give, and then over here, so k mean, right? So this is how I will be able to like I just have to pass the data set, right? I just have to pass the data set where number of cluster is equals to 5, and then we can try to find out k mean dot fit predict, right? And we can try to pass out our data set over here. Now you will be able to see all of these result. So k mean number of cluster is equals to here. So just let me do one thing. It's taking the old object KMEAN 1, let's suppose I'm going to pass, and this object dot this one, because I just had a 5 cluster, right? So here you will be able to find out that for every row, for every record, it's given as a cluster number. So cluster number starting from 0 to 4 you will be able to find out, because this is the 5 cluster we are trying to create. If it is 6, so in that case 6 number of clusters you will be able to find out. Now let's suppose I had this data frame, right? So I had this data frame x which was given to me. So x was a data frame, right? So maybe we can try to create this data frame new column label or cluster number, right, is equals to what? So cluster number is equals to this k mean 1 dot fit prediction, right? So now if I'll try to show you my x, so here you will be able to find out all the cluster number even in this particular place. Now if you will check a data set which belongs to cluster number 4, right, you will be able to find out some sort of a similarity. Data set which is having a cluster number 4. So here I'm able to get like cluster number cluster number 0, you will be able to find out certain similarity. Are you able to find out? Yes, everyone? Why our results are different, arrays are different? Because your like random state is different. So I think you should choose or change the random state just as mine, and in that way, so it will be same, right? So yes, here, so you are able to find out a number of a cluster. Let's suppose if I'm going to ask you, so try to extract all the data set which belongs to cluster number 4. Do it. Yes. So if I'll ask you that, can you please try to extract all the data set from a cluster number 4? So here I'm able to assign the cluster number, which was not there, right? So I have just done the prediction over here. And can you please try to like do these things? So yes, I think it's just a pandas query, a simple pandas queries, right? So here we can try to write X, and then my column name is cluster number, right? So cluster number is equal to 4 over here, and then we can try to do a selection operations on top of this one. So let's try to do a selection operation of X. So can I say that I'm able to find out all the data set which belongs to cluster number 4? And are you able to see some sort of a similarity? Because K-mean algorithm works on those like a distance part, and yes, we are able to see a similarity. Now from cluster number 4, because when I have checked my elbow method, so I got to know that okay, fine, so max to max 5 to 6 cluster I have to create. In this way I will be able to separate the data set. No issue, I did that. I'm able to print the cluster number, right? Now let's suppose you are the manager, so you will ask me that okay, fine, so can you please show me that cluster number 4 data set, cluster number 1 data set, cluster number 0 data set, and cluster number maybe 3 data sets, in this way, right? So you will just ask me that, can you please show me like cluster number 0 data set? Okay, I have shown you. Can you please show me cluster number 4 data set? No issue, I'm going to show you. Can you please show me maybe a cluster number 3 data set? So yes, I'm going to show you that third data set. Yeah, so cluster number 3 data set. Now you will just try to do an analysis that okay, what is their annual income, what is their spending score? Fine. So annual income is 15, spending score is 81. And again, whoever is available in this cluster, almost everyone is having a similar kind of a score, or similar kind of you can say like a annual income. So if this is the annual income, so can I say that if you will get to know the ranges of this one, you will be able to make a business decision that what kind of a offer, what kind of a credit card I'm supposed to give, and then you will be able to write a rule that person who will fall under cluster number 3, they should get this card, or they should get this kind of a offer. Plus person who will belongs to a cluster number 0, they are supposed to get this one. Fine. This is something that you will be able to do easily, and this is something you will be able to write as a rule. Now once you will write a rule, now let's suppose there is a new incoming data that we are going to get. So if there is a new incoming data, if we are going to get, so I will just do a prediction that okay, fine, if income is this one and your spending score is this one, then this person belongs to which cluster, and automatically that offer will be triggered. Yes, can I say that automatically this offer will be triggered? Because now we know the cluster number, right? Based on the cluster number and based on the ranges of the data set, because if you will just check the data, right, inside a particular cluster, so can I say that we have done a grouping over here, right? Almost all this data set looks similar. It's like all these data set are close to each other. Yes. So this is something that we do in terms of a clustering. We are able to print the cluster number. Now based on the cluster number 3, this card, cluster number 4, this card, cluster number 5, this card we are supposed to give, or maybe this much of discount we are supposed to give. Okay. Now if let's suppose there is a new incoming data set, you will be able to get. So for example, let's suppose I'm telling you that okay, so my annual income is maybe like 55, right? And my spending score is, let's suppose, 31, right? My annual income is 55 and my spending score is, let's suppose, 31. Now tell me, I belongs to which cluster? Cluster number 0, 1, 2, 3, 4, right? So if you can tell me I belong to this cluster, then for sure I will get to know which card I will be eligible for. Yes, everyone. So fine, let's try to do a prediction of that. Right, my annual income is this much and my spending score is this much. So here we can try to do like a K mean. It was a 1 or 2. So it's a K mean 1, right? Okay. So here K mean 1 dot predict, very simple one, right? So predict over here, and then we can try to pass maybe this one. 55, and then we can try to pass 31. Execute. So I belong to which cluster? I belong to cluster number 2. So now whatever rule is applicable for cluster number 2, automatically it will be applicable for me. So this is the new incoming data set into a system, right? So this is how clustering is going to help you out. So, and again, let's suppose, right, you are trying to build the model. Now, this is what we will do even in project. That is something called as customized machine learning algorithm. So let's suppose you are trying to work in a project, you are trying to build a project. That is completely fine. There is no issue with that. But sometimes what happens is that machine learning algorithm is trying to learn out of the pattern of the data set. Now, let's suppose if pattern of the data set it is not able to find out, then in that case, it is not going to give you a scalable and stable model. Now here, if you will see, so can I say that a data set which belongs to one cluster, one particular cluster is having almost a similar kind of a pattern? So can I say that if I will build a model cluster wise, so let's suppose I have a 5 cluster, right? So I have a 5 cluster over here, 1, 2, 3, 4, and 5, right? In every cluster, I have certain data set in this particular place. Now let's suppose if I'm going to build model number 1 for this one, model number 2 for this one, model number 3 for this one, model number 4 for this one, and model number 5 for this one. Yeah. So can I say that I will be able to build a more robust and stable model in this way? So first of all, whenever data will come, I will not even go for classification or regression. What I will do, I will try to find out this data set belongs to which cluster, this cluster, right? Okay, so send these things to model number 4, not to the generalized model. So I don't want to send these things to a generalized model, because when you build one single model, in that case it will be a generalized model. It will try to generalize itself on top of the whole data set which is available, and which is tough to do that, right? Which is not that easy. So for sure, if you're trying to build a model on top of the whole data set, it always creates a problem. But now if I'll ask you, right? Now if I'll ask you that, can you please try to build a model just for a data set which is available in cluster number 3, cluster number 4, cluster number 5, right? And so on. And even at the time of prediction, so first of all, you will try to find out what? A cluster number. And then you will try to go ahead with the prediction. So can I say that I will be able to get a more stable model? Yes, model will be more generalized to a different distribution of the data set. Model will be more generalized to a same distribution of the data set. So model is like something so which will work well if you are going to provide a close by data set, not a distributed data set. So this is something called as customized machine learning approach. So where we try to create a groups. Let's talk about Ola Uber, right? What do you think? When Ola is going to give you a price, right, at the time of booking a ride, or when Uber is going to give you a price, right, when you book your ride, is it going to be same? So let's suppose I'm booking one cab from Karnataka, right, Bangalore, and you are trying to book one cab from like Delhi. What do you think? We both are going to get the same price? Let's suppose distance is same. Let's suppose distance is same, right? Let's suppose our car type is also same. So even I have booked sedan, you have booked the sedan, right? I have booked for 10 kilometer, you have booked for 10 kilometer. Is it going to be same? Right? Let's suppose a petrol price variance we have considered. Then what? Again, it is not going to be same, but because traffic condition will be different, right? So traffic condition is going to be different. Cost to a company will be different, right? Cost to a company will be different. Traffic condition will be different. Petrol price will be different. Weather condition will be different. So there will be a different kind of regulations which will be applicable, right? So if that is a case, right? So can I say that they have already built a model, right? So when they do a pricing part, right? So what they used to do, so they always try to divide all the data amongst the cluster. First of all, like continent wise, then country wise, and then inside that state wise, inside that latitude longitude circle wise. They try to divide this entire things, and they try to create a cluster of the data. And for every cluster, there will be a different model. So whenever you will try to book a ride, so for sure you are trying to enter some numbers or some car like a type, and then like a from X place to like a Y place. So destination and source you are going to enter. So you are going to enter all those data sets. So what happens to those data set? Those data set goes inside one of those clusters. Yes, and then inside that, for that particular cluster, whatever is the model, it gives us a final outcome, and then that outcome you will be able to see on your screen as a price prediction. Yes. So everyone, not just Ola and Uber, does this. So everyone does this kind of things in terms of predicting your prices, or in terms of making their model more stable. Let's just assume if they would have created just one single model for the entire country, right? So is it going to work? Are the different models for the different states? There will be not just a state. So even for latitude, longitude, and districts, right, you will be able to find out the different models. Yes. So are you able to understand the meaning of customized machine learning algorithm? So everywhere we does that, right? Yeah. So everywhere we always like try to implement this customized machine learning approach, and that is a significance you will be able to see for using a clustering algorithm. By the way, again, you can try to plot it. So just a x versus y plot, you will be able to see, right? So you can just like feel free to plot it. Again, if I have to use a mini batch k-mean, so I can try to use even a mini batch k-mean. Mini batch k-mean, maybe I can try to recall. So from a sklearn, I can try to call a cluster, and then from there we can try to import mini batch k-mean. It's the same, right? So in the small batches, it try to divide the data set, and then it try to perform the clustering. So mini batch k-mean, and here you can try to provide number of cluster is equals to 5, let's suppose. And here mini batch k-mean, and here it is going to call mini batch k-mean dot fit, and here is a things. So again, 5 cluster, it is able to like create. You can try to do even prediction, right? So predict and then pass any kind of a data set. So maybe I can try to pass this data set itself, and I will be able to know. The feature got 2, expected 3. Okay, what is my X, by the way? Okay, fine. I have already added this one, right? So yes. Maybe I'm leaving like a 4. Yeah, so something it will be able to give you based on the data set. Yeah. So here is a clustering approach by using your k-mean algorithm, right? Maybe we can try to use a DBSCAN, and we can try to showcase again a similar kind of a things. Maybe we can try to use a SC clustering algorithm, and then we can try to perform a similar kind of operations, which is again pretty much possible, right? So maybe I can try to call your import sklearn, and then dot cluster, and then import basically DBSCAN. DB, what happened? It is not able to give me auto suggestion. SCAN, DBSCAN. Sklearn, sorry. So from it will be right. So from, yeah. So from sklearn, this one, import DBSCAN. Fine, done that. Now what we can do is, so maybe we can try to pass this data set, same data set that we have used inside this DBSCAN, and then we will be able to perform these kind of operations, which is Pretty much possible, right? So just try to pass this entire data set inside the DBSCAN, and then you can try to print the labels, you can try to print the indices and all those things. So here we can try to call maybe a DBSCAN object we can try to create. And here, so DBSCAN, okay, DBSCAN. Now here, so whenever you are trying to use our DBSCAN, so I think we talked about epsilon values, EPS, right? And we talked about a minimum number of sample to form a particular cluster, right? Or to make something as a core point, right? So I think we talked about a core point, we talked about a border point, we talked about outliers over there, or called as noise points, right? We talked about a epsilon over here. So in case of a DBSCAN, so we can try to set, otherwise epsilon value will be 0.5. We can try to set a number of minimum sample to make some points as a core point. But yeah, so minimum sample, even you can try to keep it as a 5. So both is completely fine. It's not going to affect you. And these are the hyperparameter. So you can just keep on changing all of those things one after another. Okay. So now here, right? So here we have EPS is equal to 0.5. We can try to maybe change it, and number of sample we have. So here we can try to change that as well, right? So we can try to change that as well over here. So minimum number of the sample which is required. And let's suppose I'm going to build this object. Now DBSCAN dot fit I can try to call, and then we can try to pass all of our data set. So once I'm going to pass this data set, so let's suppose I have taken this one, right? This is as a data set. Ideally, it should be like this and this, but yeah, let's suppose I have taken this data set. I'm doing a clustering. So now I'm able to build a cluster with the help of DBSCAN. But how good this cluster is, how bad this cluster is, so maybe we can try to find out. So DBSCAN dot labels, and what is the labels it has created for this entire cluster. So even you will get to know that what is the label of this entire clusters, or how many number of the clusters that it has created, how many core indices it is having. So each and everything, right? Each and everything you will be able to find out. A number of clusters, like a number of noise data set, you will be able to find out each and everything. So let's try to find out each and every numbers over here. So this is the labels that we have created. Yes. Now, once this labels is ready, and let's suppose if we have supposed to find out maybe a number of clusters, right? So here it seems like it is trying to create only one cluster. Now let me just change something. EPS value I'm going to reduce, and then minimum number of sample I'm just going to keep it as it is. Nothing has changed in DBSCAN, so minimum EPS is equals to 0.1, because it looks like data set is too close to each other. I'm supposed to take annual income and spending score only. So, okay, X is equals to this much. So number of labels is showing as -1. Data is very close. Yes, that I can see. So in that case, maybe minimum number of sample I'm going to increase, because all of those data set is very close. Still very close, and I just have like a 200 number of records. So in very less radius, let's suppose I'm looking for 100 data set, and EPS value is equals to 0.001. Still, let's suppose EPS value is equals to 1. EPS value I can try to choose based on my needs. So that's like a completely fine. We can try to do a hyperparameter tuning, and we can even try to find out like a value of a EPS in this particular sense. So that is like a possible. Okay, so it is just giving me like this as a label as of now, right? Nothing else. It is trying to like give. So ideally, so let's suppose if there is a multiple clusters that it will be able to form. So maybe I can try to take another data set, right? And then I can try to test it. So in that case, it is giving me like just a -1 label. It simply means that there is only one label which is available, or only one cluster it is able to understand based on this EPS value and based on this particular minimum sample, right? So again, this is just a hyperparameter, and the pain with this one is you have to keep on trying that how many clusters. Yeah, now you can see some 0, 0, 2, 3, 4, I believe. Yes. So now cluster value has changed. So there is a multiple clusters that we are able to find out. Now, what is the total number of clusters? So here maybe we can try to find out a set of it. So what is the total number of clusters? So 1, 2, and then length of the set I can try to find out. Yes. So length of the set. So total number of clusters that it is able to form is equals to 7 with this one. Yes. So this is the total number of the cluster that it is able to find out. Now, wherever it is trying to give -1, -1, -1, right? So wherever you will be able to find out that -1, so it simply means that it is representing a noise point over here inside a label. Wherever we have that one, it's a noise point, or it's called as outlier. So -1 is nothing but a kind of a data set which it was not able to accommodate in any of the cluster. That is something called as -1. So even let's suppose if I have to find out an outlier, right? So which data set is an outlier for my record? Okay, so let's suppose I have X over here, fine. And now I can try to like label this data set with a cluster number, and cluster number is equals to what? So cluster number is equals to this DBSCAN dot labels. And here, so we can try to check X, right? And wherever we have -1, -1, -1, it simply means that it is not able to accommodate this data set within any of the cluster, and so it's a -1. Is it making sense to all of you? Yes. Can you show the EPS and minimum sample you have used? So EPS is equals to 1 and a minimum sample is equals to 3. Again, see, this is the hyperparameter. So this is not a fixed entity at all. So you are supposed to do experiments. You should like keep on doing an experiment. Then only you will be able to find out. And again, this is not a stable value. So here you are supposed to find out the score for sure. You are supposed to find out that what is a score of this entire like a clustering algorithm. Maybe you are supposed to convert this data set by using a standard scaler. So transformations you have to do, and then you can try to go ahead with the clustering. So there are, right? So there are different like things by which you will be able to evaluate it. So let's suppose I have built this model, but I don't know like what is the accuracy of this entire clustering algorithm. So maybe we can try to call from sklearn, right? So we can try to import what matrices over here. And once I will be able to import the matrices part over here, so here what we can do is, so maybe we can try to pass matrix dot Jacobian similarity score. We can try to pass matrix dot adjust random score. So all those things I will be able to print. So here matrix. So I think we talked about evaluation matrices. Jacobian coefficient we have discussed, right? So here accuracy score, and then I will be able to find out many more things, right? So F1, Volkswagen, Hamming loss. So there are many more things that I will be able to calculate. So maybe I will be like interested into a random score or random score, right? I can try to calculate that one. Maybe I'm interested into a Jacobian, right? So matrices, MET, So matrices dot Jacobian score. So yes, I will be able to calculate a Jacobian score, not to calculate a Jacobian score or to calculate a adjusted rand score. What I'm supposed to do is, so I'm supposed to provide the true label and the label. So actual labels which was given by a user and the labels which was given by the system. So this is the labels. Can I say that it is given by a system? Yes. Can I say that this is the label which was given by the system for DBSCAN, right? Maybe we can try to do one thing. So we can try to maybe print this one, right? So maybe we can try to use this previous data set, the result of k-mean. So k-mean has also labeled my data set in terms of cluster, right? So I can try to provide one as a true label and maybe k-mean as a true label, and then hours as a label, and then I will be able to understand what is the score of it, right? So what will be the manual label as it is unsupervised? Manual label will be given by your business user in general, right? So for a sample of the data set, they will always provide you this kind of a labels. In actual problem, how the client will give the ground truth. So client is the someone who is aware about the data set, right? Client is like someone who is generating a data set. So they are aware about that in between what to what range, which data set it should produce, because the system belongs to them. So for sure, it's their responsibility to provide you a sample data set for the testing purposes, right? So you can just try to provide like a true label and labels. So just try to do it. What over here? So let's suppose k-mean is your client, right? And whatever k-mean has given to you, so that is a true, right? And your DBSCAN is basically a testing algorithm. So in this way, you can just try to test it. And these are the matrices that you can try to call. You can even try to call a purity score that we have already discussed, right? Or you can always try to call maybe a Silhouette score. So even Silhouette score is possible, purity score is possible. So just matrix.Silhouette score, and then you will be able to calculate it. So in this way, you will be able to calculate accuracy of any of these data sets at any point of a time. Yes, so anyone who can do this, anyone who can try to take a client data set as a k-mean and then you're testing as a DBSCAN and then try to tell me what is the score, what is the Jacobian score, what is the rand score. It will be very, very low because I can clearly see that my DBSCAN model is not that great over here, right, in terms of giving me a prediction. And that's a major issue. Although DBSCAN is a very good algorithm in terms of adjusting itself, but the major problem over here is that if you are not going to pick and choose a perfect value of EPS and a number of a element inside a particular cluster, it is going to give an issue. And data set is very, very less over here. Yes. So Nilesh is saying that this score is very, very less. It's 0.57. This is what he is able to get. And again, Raghav, so what is your score? I can see your code. Again, Mohit, so he has pinged me the score. So yeah, this is fine. Right, so this one is completely fine. Label you are trying to pass from the k-mean clustering, you are considering that as a client, right? And that you are considering as a ground truth. And then you are trying to pass this one. That's completely fine. Jacobian similarity score, Nitin is able to calculate. So fine, yeah. So in this way, you can try to calculate a Jacobian score. You can try to calculate a rand score. You can try to calculate a rand score. Silhouette score. You can try to calculate. You can try to calculate a purity score. So in this way, we always try to test a model, a clustering model that we try to create, whether it's a DBSCAN model, whether it's a SC clustering model, or whether it's a k-mean model, or maybe it's a Gaussian mixture model, right? Each and every models we are going to test it by using these parameters itself. So Jacobian, random indexes, purity score, Silhouette. Is it fine, guys, to everyone? Okay. So if this one is fine, maybe we can move ahead with something else over here. Yeah. So let's try to understand something else. So what is next that we can try to understand? Yeah, so Nilesh is saying that Jakardian score is this much. Yes, that's true. Jakardian score is you are supposed to provide the true label and then you are supposed to provide the prediction label. So true label is coming from your K-mean, let's suppose, and prediction label is your prediction label of your DBSCAN. Provide it, that Y column, and then you will be able to get the answer in the easiest possible way. Okay, now we can try to maybe take a break of 15-20 minutes, and after this particular break of 15-20 minutes, so maybe we can try to uh, learn some sort of naive Bayes algorithm. Maybe, yeah, we can try to learn. Yes, so we can try to explore what is naive Bayes, because naive Bayes is a small one. I don't think that it will take more than 1 hour of time for me to explain, right, theoretically. So we'll try to prove those things, and then immediately we can try to build the model part. So in this way, even naive Bayes will be covered. And if I'll go to iNeuron website and iNeuron, if I'll go over here, so where is your full stack? So okay, so labels, yeah. So regression, so fine. I think we have discussed logistics. So I believe we have discussed decision tree. So almost everything. Have we discussed SVM, SVR? Yes. Okay. Naive Bayes we have not discussed. So I'll try to close this one today. Ensemble, I think we have discussed. We have seen our models as well. Boosting, theoretically, a little bit we have discussed, but not completely. So I'll come to this point once I'll close this one. Stacking, so I believe we have discussed stacking. KNN, we have discussed KNN, ball tree, KD tree. Dimensionality reduction. So PCA, we have discussed what is a single value decomposition, what is a stream plot, what is a eigenvalue decomposition, what is a PCA. We have discussed clustering. So K mean plus plus HC or these scores, right? So we have discussed. So let's try to talk about first of all your this one naive Bayes, which is a long awaited pending one. We have not even discussed the theoretical part of it. So we'll try to close naive Bayes, and there is something over here which is related to that naive Bayes. So we can try to close this topic, because this topic is very, very small. Because this is just a brief overview and idea of NLP. That's the reason so it's written as NLP basic. It's not at all like a advanced topic in NLP. It's very, very basic, right? A major topic you will be able to find out in NLP over here. So transformer, attention. So these are the major topic inside NLP. So we'll try to cover these two parts, and then maybe tomorrow, so we can try to see XG boost, because boosting, we have to do experiments. We have not done that. Dimensional reduction, it's already done. So we can try to reuse it, and boosting, and maybe anomaly, we can try to discuss tomorrow. So these two will try to cover tomorrow, and then we are good to go with the project part. So we can start building an entire machine learning pipeline. We can start building a project after one project, so we can try to touch this time series part. And yeah, so I think this will be great approach. SBM practical, XGBoost practical. Tomorrow we can close it. So anomaly and this one, we can try to close it in tomorrow's class. So fine, guys, let's try to take a break of maybe 20 minutes, right? It's a 4:45 as of now. So by 5:05, we will be on break. And then after that, we'll resume and we'll try to cover a naive Bayes, first of all, theoretically, because it's just a classification algorithm and it's easy to understand, just a probabilistic classification algorithm. And then we can try to see it's like a theoretical plus practical part of it. Yes. So fine, let's take a break of 20 minutes. Okay, fine everyone. So I think we are back, right? Okay, so somebody asking question that what is a data leakage? So see, data leakage, if I'll talk about in a general way, right, in a general term. So data leakage is nothing but, so let's suppose if I'm trying to like share some sort of a secure data set, right, with some unauthorized user. So that is something called as data leakage. But if we are talking about a data leakage with respect to a machine learning, so data leakage is something like, let's suppose I have a training data set, I have a test data set, and let's suppose there is some data set which is common in between training and the testing data set. So in that case, your test will not be a unbiased test, it is going to be a biased test, and that is something called as data leakage in terms of a machine learning. So where there is some sort of a common things in between your training as well as in between a testing a data set. We need holiday at least tomorrow, please. I think this is a festival season, right? So if you'll start giving a holiday, in that case, things will be delayed. So I think it's not possible tomorrow. Let's have a class tomorrow, right? As per a schedule. Anyhow, we have a Deepavali next week, so that we all can enjoy a Deepavali without taking a break. So how to identify a data leakage? So it's very simple. Like, see, just try to check a common things between training and test. So let's suppose I have a training data set. Let's suppose I have a testing data set. So we can easily check what is a common data set between training and testing. So in this way, we can try to check a data leakage. Simple. Exactly. Holiday करते बैठेंगे तो transition कैसे करेंगे? Exactly. So our priority is to make a transition, right? And even in your batches, we are like making a transition on a regular basis. So I believe we should focus on a transition. Holiday wise, we can celebrate holiday anytime. That's not an issue at all, right? So we have a complete life in front of us, and anytime we can try to enjoy these things. Now let's talk about a naive Bayes algorithm. So what is naive Bayes and what kind of a problem I can solve with the help of naive Bayes? All those things we are going to discuss. So first of all, mathematically, let's try to understand what is naive Bayes algorithm. Okay. So naive Bayes is an algorithm, or it's a way, or it's an approach by which you will be able to solve a classification problem in general, and it's a probability based equation, it's a probability based algorithm. But let's suppose if I have x1, if I have x2, if I have x3, and so on, and if I have y as a label, right? So we all know that classification is nothing but it's a supervised machine learning approach. So let's suppose if I have x1, x2, x3, and if I have y, and independently, if x1 is having a relationship with y, x2 is having relationship with y, and x3 is having relationship with y, in that case you can try to utilize a naive Bayes algorithm independently if it is having some sort of a relationship, right? Nilaksh is saying that I thought data leakage is when we process a data without splitting, example, applying the standard scalar transformation, etc. So the model is biased. I had seen the test beforehand. See, this is a YouTube definition you are talking about, right, Nilaksh? So this is a definition that you have received from a YouTube, I believe, and you are talking in that sense. And that is a fact, even if most of you will agree. A simple meaning of a data leakage is if there is a common things in between, right, a training and a testing data set, that is called as data leakage. Now let's suppose the kind of instance that, or the kind of example that you have received from the YouTube. So you are saying that if I will try to do a standard scalar before training and testing, right, so that will leads you to a data leakage. So that is one of the instance of a data leakage you will be able to assume, because just try to understand, when we do a standard scalar, let's suppose we have not done a split of the data, but we are trying to apply a standard scalar. Now whenever it will try to apply a standard scalar, it will try to shift a scale of the whole data set, right, with respect to the existing whole data set. So here you are trying to create a mixture of the whole data set to perform this standard scaling, and then you are doing a training and testing. It simply means that there is some common things in between whole data set you are trying to introduce. So it is, that's the reason it's called as Like if you are trying to do a standard scaling before doing a train and test split, so that may introduce, right? That may introduce a data leakage. So it's just one of those instances, but that is not an actual definition, by the way. So hope you are able to understand it, and don't go after all the YouTube definition, right? So you're not the first one who is asking me this question. I think I have received this question so many times, and I always answer in this way. Simple. So try to understand the real meaning of it. Forget about those meanings that you have received from somewhere else. Okay. So now naive Bayes, right? So naive Bayes is an algorithm by which you will be able to classify a data set. So where you have some sort of a relationship between your dependent and your independent variable, right? A direct relationship in between these two. So then you will be able to say that, okay, fine. So I can try to use a naive Bayes algorithm. Now, equation wise, if I would like to talk about this naive Bayes, so it says that probability of occurrence of, let's suppose A, right, when probability of occurrence of B has already given to you. So this is what naive Bayes equation says. So probability of occurrence of A when B is already known to you, right? That is something called as naive Bayes. So here, this probability we can try to define in this way, that probability of occurrence of A when B is already known to me into a probability of occurrence of B divided by a probability of occurrence of A. So this is called as naive Bayes equation for a categorical data set. Again, so there is a naive Bayes equation you will be able to find out for a continuous data set as well. So after like having an explanation on this part, so I'll try to come to the continuous data set, but this is something called as categorical. So here, let's suppose if I'm trying to make a decision, right, that whether I should go outside or not tonight, right, for a party. So that depends upon so many factors. So let's suppose one of this factor X1, right? So one of this factor X1 is, so maybe money, right? X2 maybe weather condition, and X3 maybe whether I have friends or not, right? So these are the meaning of X1, X2, and X3 column. And I have to make a decision that whether I will be able to go outside or not. Now, can I make a statement over here that if I have a money, right, to spend, a lot of money to spend tonight, right? So in that case, my decision will be yes. Yeah. Now, can I say that if I have maybe a friends, so maybe I can go outside? Can I say that if weather condition is good, so maybe in that case I may try to go outside? If all these three conditions satisfy, even in that case I may go outside. So basically I'm trying to make a decision, so whether I should go outside or not, and based on that I will be able to make this kind of a decision. I think here it will be probability of B upon A. So let me just rectify this one. So probability of occurrence of A when B has already occurred is equals to probability of occurrence of B when A has already occurred into probability of occurrence of, this will be A. This will be A divided by a probability of occurrence of B. So this is something that you can try to write down, right? So this is the correct equation. You will be able to find out for the naive Bayes. Now, so here, what I was trying to talk about is probability of occurrence of one is going to affect your final result. So maybe in that case, and when you have an independent probability, or when you are trying to find out a final result based out of maybe independent occurrences of one of the instances. So in that case, you can try to use naive Bayes equation. So this is coming from your Bayesian theorem, by the way. So it's a Bayesian theorem by which you will be able to utilize this naive Bayes, and you will be able to find out that whether there is a probability to go outside or not if I have a money. Means if this has already happened, if I already have a money, so in that case, I will be able to go outside or not. This is what it signifies, or this is what it defines. So I will be able to go outside or not if I have a money, if I have if weather is good, or if I have a friend. It is nothing but, so
probability of going outside. So when I already have money, maybe I have a weather, or maybe I have a good weather, or maybe I have a friends, right? So this is what it defines. So let's try to take one of the data set which I usually take all the time, called as this weather temperature data set, and based on that we can try to perform this kind of operations, and we will get to know so how we can solve a problem with the help of this Naive Bayes equation or Bayesian equation. So here, data set wise, maybe we can try to consider this outlook, temperature, humidity, windy, and whether I will be able to play golf or not. So let's suppose we have a data set outlook, and then we have a temperature, we have a humidity, we have a windy, and we have a play golf, right? So this is the column set we have given to, like this is the column that is given to me, and maybe based on that, so I'll try to decide whether I will be able to go outside or not for playing a golf over here. This is one of the very common example you will be able to find out even over the internet, and easy to understand. That's the reason so I always take this kind of example. So here, let's suppose outlook wise, so we have a rainy condition, so RAINY, rainy condition, and maybe I can have a sunny condition outlook wise, and maybe we have a overcast condition. So rainy, so maybe I can try to like take this data set rainy, and then maybe overcast, maybe we have sunny, we have again sunny, we have again sunny, overcast, then maybe we have a rainy, we have a rainy condition. Temperature wise, so there may be a hot, there may be a hot temperature, there will be a mild temperature, there may be a cool temperature, there may be a cool temperature, there may be a hot, there may be a mild, there may be a cool, and there may be a hot temperature. Now here, humidity wise, let's suppose we have a high humidity, we have high humidity, we have high, we have like a low humidity, we have low, we have normal, we have normal, we have high, and we have low. Now windy condition wise, so let's suppose this is like true, this is like a true, this is true, false, false, true, false, false, true. Now playing golf wise, so maybe I won't be able to play a golf, I won't be able to play a golf, I won't be able to play a golf, I will 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 be able to play a golf, I won't be able to play a golf, right? So this is a data set that we have already prepared, where we have this column, this column, this column, this column as a feature column, and this is nothing but my label column which is given to me. So I have to make a decision that whether I will be able to play a golf or not. Now playing a golf independently depends upon the outlook condition. Playing a golf independently depends upon the temperature column. Playing a golf independently depends upon the humidity column. Playing a golf independently depends upon the windy, right? Even in case of a sentiment analysis, right? So we try to use this algorithm a lot. So even in our sentiment analysis project, so we are going to use a Naive Bayes, because let's suppose if I'm going to give you a word, right? So if I'm going to like write up the line over here, so here service is very poor, class is very bad. So here, can I say that all of this is representing a negative sentiments? Yes, both of these two is representing a negative sentiments. Agree everyone? Yes. So both of these two things are representing a negative sentiments over here. Can I say that this negative sentiments depends independently on this, and this, because this is the only word which is having some sort of a relationship with this one, right? This is the only word which is having a relationship, independent relationship with this one. So it actually depends upon a individual contribution of a particular column. Let's suppose if I'm going to divide this entire data set into a columns, right? So, and this is my label column. So can I say that independently, if I will be able to find out a relationship of this data set with this one, then only I will be able to do a prediction if some new lines comes into a picture. Yes. So it's a independent, like a feature, or based on the independency of the data set. If we have some sort of a relationship with the label column, in that case, we can try to use a naive Bayes. So there is a special case you will be able to find out. It's not like you should use naive Bayes each and every places. No, first of all, you are supposed to observe that whatever attributes which is given to you, so whether it is having some sort of an independent relationship or not. If it is having an independent relationship, only in that case you are supposed to use a naive Bayes. Otherwise, you are not supposed to use a naive Bayes, which is like a very simple, right? So here we have an independent relationship between this poor and this negative sentiments. Maybe if I have like some word, session is very good. So maybe this is a positive sentiments, right? So here this positive sentiment is not been defined by this, or this. This is defined by this one. So there is a independent relationship you are supposed to learn out of this many relations which is available. And if you are able to learn, then only you can say that you will be able to classify this kind of a example. And that is the reason I told you in sentiment analysis, yes, we are going to use a naive Bayes kind of a equation. And even when you are going for the interview, if someone is asking you that, okay, so let's suppose if I have to build maybe a sentiment analysis kind of a system. So what is the preferred algorithm you are going to use? So you will simply say that if there is some independency between the dependent data and the independent data, or like a labels and a feature we have, in that case, I would like to use a naive Bayes equation, which is a very simple one, right? So I would like to use a naive Bayes in this particular place. Fine. So similar case, you will be able to find out even over here. So I'm supposed to decide whether I can play a golf or not based on this condition: outlook, temperature, humidity, windy, and I'm going to play a golf or not. Your voice coming like a robot, is it? I think I'm not a robot, at least. People are saying no, so I think you should check your mic or something, your headphones. It's clear, no, not an issue at all. Net slow hai. Bhaiya, aapka sir ka fast. Yeah, check your internet connection in that case, because mine is good. Right. You word day and night, no less than a robot. Yeah, because I speak a lot, right? Maybe because of that it looks like a robotic voice. Okay, now move ahead. Fine. So let's suppose this is the data set which is given to me: outlook, temperature, humidity, windy, and whether I will be able to play a golf or not, right? So we know that, okay, so there is some independent relationship we have in between, and maybe we can try to use a naive Bayes over there, because this is what equation says, that probability of occurrence of A when B has already happened, right? So here what you are supposed to find out. So can I say that you are supposed to find out probability of playing a golf when this has already happened? Can I make this statement? Yes, everyone? Can I make this statement that probability of playing a golf when outlook, temperature, humidity, and windy has happened independently, because outlook, temperature, humidity, and wind condition is independent feature of each other, and independently they have a relationship with the Y, which is my playing a golf or not playing a golf, right? So this is something that we are supposed to understand in a very first place before applying a naive Bayes algorithm, that whether there is some independency available in between a data set or not. And if it is available, so yes, we can go ahead and we can try to apply it. Okay, now here, right here, based out of this data set which is given to me, so maybe we can try to build a table, right? We can try to build a table. So maybe first of all, we can try to build a table for this one, for a calculation, because we are doing a manual calculation, right? So let's suppose whether we will be able to play a golf or not. For this one, if I have to build a table, so here if I will try to build a table for my Y column, why we are building a table, we will try to understand. But first of all, let's try to build a table over here. So here, table wise, right? So play golf, right? Now, how many different labels do we have? So can I say that we have two labels, yes and no? Yes. So can I say that we have two labels? So we have either yes or we have either no over here. Okay, no issue. Now, how many yes we have and how many no we have over here? So can I say that 1, 2, 3, 4, 5? We have 5 yes, 1, 2, 3, and 4. So we have 4 no. In total, we have 9 instances, right? Now just tell me, what is a probability of occurrence of yes out of the whole data? What is the probability of occurrence of yes? So can I say that it's nothing but 5 by 9? What is the probability of occurrence of no? So it's nothing but 4 by 9. So 9 is the total instances. Out of that, 5 times we have yes. Out of that, 4 times we have no. Fine. This table is done. So probability of yes or probability of no, we are able to find out over here. That's fine. So probability of yes or probability of no, we are able to find out in this particular place. Okay. Now, once we have this particular table, then we can try to move into the different table. So let's suppose we can try to build a Outlook table, right? So maybe we can try to like build a Outlook table over here. So for Outlook column. Now here, in case of Outlook column, how many distinct attributes do we have? Can I say we have a rainy, we have overcast, and we have sunny? So in total, we have 3, right? So we have rainy, we have overcast, and we have sunny. So in total, we have 3. Okay, no issue. So we have basically like a rainy, we have overcast, and we have sunny. These are the 3 things that we have. I'm just writing this abbreviation of it, like just a single word, right? Okay. So here, yes, and then here we can have like a no, and then like a probability of yes we can try to count, and then probability of no we can try to find out. Okay, and then maybe we can try to find out a total. Now if I'll ask you a question, right, because we are trying to establish the independent relationship between our feature and a label, right? Now if I'll ask you a question, that how many times, right, look into this data, how many times we had a rainy condition, right, and we have played a golf? So how many times we have a rainy condition and we have played a golf? So we have a rainy condition and we have played a golf one time, right? Okay, so rainy condition, we have played a golf one time. Yes, we have played the golf. How many times we have a rainy condition and we haven't played a golf? Just look into this data. So I believe this one no, this one no, and this one is no. So in total 3. Okay, done. How many times we have a outlook, overcast condition from outlook column, right? And we have played a golf. So how many times we have an overcast, we have played a golf? So I believe 1 time, right? This data set. So 1 time. How many times we have a overcast and we haven't played a golf? So overcast, yes, overcast, no. So only 1 time. How many times we had a sunny and we have played a golf? So how many times we had a sunny and we have played a golf? So I believe 3 times, right? So 3 times we had a sunny and then we have played a golf. Now, how many times we have a sunny, we haven't played a golf? Yes. So can I say 0 times? Okay, fine. So 0 times over here. Now, if I will ask you a question, right? If I'll ask you a question, what is a probability, right? What is a probability that there will be, right? So what is the probability that there will be a rainy condition, right? And you will play a golf. So probability of yes. So how many total data set we have in yes? Just tell me how many total data set we have in yes. So 5 data set. How many total data set we have in no? So can I say that we have a 4 data set? If I'll ask you a question that how many times we have a rainy condition and we have played a golf? So can I say that we have played golf only 1 times when there was a rainy condition out of these many number of times which we have played a golf? So can I say that it will be 1 by 5? Yes. Then if I'll ask you a question, how many times we have played a golf when we have a overcast condition? So can I say that it will be 1 by 5? How many times we have played a golf when we have a sunny condition, right? So can I say that it is going to be 3 by 5? Yes. Okay. How many times we haven't played a golf when we had a rainy condition? So can I say that it is going to be a 3 by 4? It is going to be 1 by 4. It is going to be 0 by 4 is equal to 0, right? Probability is equal to 0 over there. Okay, fine. So here we are able to find out these things. Now, if you will try to sum this up, you will be able to find out 100%, right? And here you will be able to find out 100%, right? If you will try to sum this up, means one you will be able to find out. Okay, so outlook column is done. Now, same thing I will try to do for the next column, which is a temperature column. Temperature column, right? So I'll try to do the same thing over here. Why we are doing it? Very soon we are going to understand. Just focus on this one. Now, in temperature column, how many distinct attribute do we have? So can I say that we have a hot, we have cool, and we have mild? These three things we have, right? So we have hot, cool, and mild. Okay. So fine, we have hot, we have cool, and then we have a mild. Okay. Now, yes, no, probability of yes, and probability of no. Just try to understand over here. We are trying to establish a relationship between an outlook column and my final label column. Can I say that over here? Yes. So we are trying to establish a relationship between our outlook column and our label column, a final column, because this is what we are trying to find out, right? How many times we had a rainy condition, we have played a golf. So from where we get to know we have played a golf or not? From this Y column. So yes, we are trying to establish this particular relations. Now let's suppose we are talking about the temperature. Let's try to build this table. So let's try to understand this temperature part. So here, if I'll ask you how many times there was a temperature is hot and you have played a golf. So how many times temperature was hot, right? Temperature was hot and you have actually played a golf. So this no, this yes, and this no. So can I say that only one times you have played? How many times you haven't played when temperature was hot? So I believe 3 times. How many times it was a cool temperature? So cool temperature and you have played a golf. So can I say that 3 times you have played a golf when temperature was cool, and in case of no, can I say it's 0, right? Okay, 0. How many times we had a mild temperature and we have played a golf? So can I say that mild temperature? So I think we have over here, no, and we have yes. So 1 yes, 1 no, 1 yes, 1 no. Okay. So total yes is equal to 5. Total no is equal to 4, right? So probability of yes when there was a hot temperature, probability of like a golf which I can play. So when there was a hot temperature is equals to 1 by 5, here 3 by 5, here 1 by 5. Probability of not playing this golf is equals to 3 by 4, 0 by 4, 1 by 4. Okay. So this is something that I will be able to get. Now let's try to work on the another column. So what is my next column? My next column is humidity. Humidity. Okay. Now here, so humidity wise, how many attributes do we have? So I believe we have high, low, and we have a normal. Okay. So we have 3 attributes. So we have a high, we have low, and we have normal. Okay. Now here, how many times we have like a humidity high and we have played a golf? So humidity high and we have played a golf only 1 times, I believe. So yes, no, probability of yes, probability of no. So how many times we had humidity high and we have played a golf? 1 time. How many times we have humidity high and we haven't played a golf? So 3 times. How many times we have humidity is equals to low and we have played a golf? So low, 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 and yes, yes. So 2 times yes, and one time no. How many times we have a normal condition and we have played a golf? So normal, yes, yes, and we don't have any other normal. So it's going to be 2, 0. Okay. So total is equals to 5. Here is equals to 4. Probability of yes is equals to 1 by 5, 2 by 5, 2 by 5. And for no, so it is going to be 3 by 4, 1 by 4, and 0 by 4 over here. Okay. Now the remaining column is a wind column. So maybe we can try to draw a same thing for a wind. So in case of wind, so yes, no, probability of yes, probability of no over here. And we have either true or false in terms of a windy condition. So how many times windy was true, wind condition was true, and then we have played a golf. So we have a true over here, true over here, true over here, true over here, and true over here. So we are able to find out only one yes, and we are able to find out how many times no. 1, 2, 3, and 4. So 4 times no we are able to find out. Now in terms of like false, so we have 1, we have 2, we have 3, we have 4. So in terms of 4 false, all yes, 0 no. So 4 yes and 0 no. In total 5, 4, 1 by 5, 4 by 5, 4 by 4, 0 by 4. This is something that I will be able to get. Okay. Now, let's suppose I have given you a new data set, right? So here condition is sunny, and the situation is basically like cool. Now this one is high and this one is false. Now you have to give me an answer. Fill in the blanks over here, that whether I will be able to play a golf or not. This is the answer we are supposed to find out. That what is the probability that yes, I will be able to play a golf, and what is the probability that no, I will not be able to play a golf. This is something which I'm supposed to find out. Yes, that is a problem statement. So is this things fine to everyone? What is the column statement that we have? And these tables are fine, right? All these 5 tables that we have created. Is it fine? Yes. Okay. So now we are supposed to find out that whether I will be able to play a golf or not. So I'm supposed to find out that what is a probability, right? What is a probability that I will be able to play a golf, right? So how I can write the equation? So I'm supposed to find out that what is a probability that yes, I will be able to play a golf, but based on what condition? So based on this condition, if there is sunny, there is cool, there is high, there is false, means if outlook condition is sunny, if temperature condition is equals to cool, if my humidity condition is equal to high, and if my windy condition is equals to false, I'm supposed to play a golf. I'm supposed to find out that I'm supposed to do a prediction that whether I will be able to play a golf or not today, right? So Dipinder is saying pakka khelenge. Yeah, Dipinder, for sure. Okay, so here we are supposed to find out that whether, so we are supposed to find out the probability, so whether I will be able to play a golf or not if this things has already happened. Now what thing has already happened over here? So can I say that sunny, cool, high, and false has already happened? Right? So sunny, cool, high, false. Can I write this equation in this way? Are we able to understand the meaning of this equation? So we are trying to find out that whether I will be able to play a golf or not, means yes or not, if this condition is given to me. And I'm supposed to find out whether I won't be able to play a golf or not, means no condition, right? When sunny, cool, high, and this one is given to me. So can I say that if I will be able to find out the probability of either of these, I will be able to get my prediction? Agree, everyone? This is the equation that we are supposed to solve, right? So at the end of the day, we are supposed to find out probability of playing a golf or probability of not playing a golf. Based on what? based on the attributes, based on all of these features which is given to me. This is the only thing that we are supposed to find out. Nothing else we are supposed to find out over here. So okay, no issue. We can try to solve this problem easily, right? So easily we will be able to like solve this problem, and we can try to find out that whether I will be able to play a golf or not when this is the situation which we have in front of us. Okay, so if I have to rewrite this equation, so how I will be able to like rewrite this equation? So yes, if I have to rewrite this particular equation, this is the condition for today. So let's suppose probability of playing a golf, when this is the condition today. Today means I'm referring to all of these four, right? When there is a sunny, cool, high, and all those things is given to you. So here, as this base equation says that probability of occurrence of A when B has already given is equal to probability of occurrence of B when A has already given to you, probability of occurrence of A divided by probability of occurrence of B. This is what our equation says. Naive Bayes equation says. So here we have a four things which is given to me, right? A combined probability if we have to find out. So here we can try to say that probability of, right, today condition. So today condition is sunny, cool, high, and false, right? So here probability of sunny, yes, into probability of cool, yes, probability of high, yes, probability of false, yes, right? So can I say that I can rewrite this equation in this way, just as a multiplication of this entire equation, right? Because I'm just trying to follow the original equation, that's it. Into probability of yes, so probability of yes divided by, right, divided by probability of today. So what is the probability of today? So probability of today is nothing but your sunny, like a rainy, and sunny, cool, high, false, all those things. So today. Now just try to do one thing. So what is a probability of like a sunny when we have already played a so when we have already played a golf? What is the probability of cool when we have already played a golf? What is the probability of high when we have already played a golf? When we have, what is the probability of false when we have already played a golf? And what is a probability of yes? So can I say that I will be able to find out all of these values from this particular table that we have already created, right? So from where I will be able to like get these things. So let's try to understand this particular part. Just tell me one thing. What is a probability of like sunny, right? When we have already played a golf? So can I say that what is a probability of sunny, right? When we have already played a golf, when we have played a golf, right? So can I say that it's going to be 3/5? So fine, this one is going to be 3/5 into what is a probability of like cool, right? When we have already played a golf. So can I say that we can try to look into this temperature column, cool, right? So it's going to be 3/5. So okay, we can try to write down 3/5 over here. What is a probability of a high? Humidity is equals to high when we have played a golf. So what is the probability of humidity is equal to high when we have played a golf? 1/5 over here. So see how easy this calculation is, right? So we have just created a table and then we are just trying to put up the values. That's it. What is the probability of false when we have played a when we have played a golf? Can I say that it's a 4/5, right? It's a 4/5, right, everyone? Yeah, false. So yes, 4/5 over here. Now, what is a probability of yes? So can I say that probability of yes is equals to 5/9 over here? So probability of yes is equals to 5/9 over here. Forget about the denominator part. We can cancel this out with the true and false condition. Now, anyone who can give me this calculation? We used to do this in a +2 boards. Yeah, that's true. So in fraction, if you can give me the result in fraction. And can I say that this denominator part is going to be constant for yes as well as for no? So can I say that maybe I can try to find a probability of playing a golf today, right, with this proportionality constant, because this is just a constant 1 by maybe c. So this is going to be constant for like a yes, and this is going to be constant for a no, right? So what is the probability? So someone is saying, most of you are saying that 0.032. So this is the probability that I will be able to play a golf, right? Now just try to find out what is the probability manually, right, that I won't be able to play a golf today, right? So here, if I have to find out the probability, so sunny no. So what is the value? Sunny and no. So sunny no is equals to, yeah, sunny no is equals to 0 in this particular case. Okay, this is going to be 0. And if you are going to multiply anything with the 0, so it is going to be 0. Now here you will end up introducing a small problem in case of a Naive Bayes. So let's suppose if there was some instance which is not at all available. So in our table, so many places we have encountered 0, 0 and zeros. So if there is something which has not happened so far, so forth, so in that case, it is going to nullify the entire values itself, and in that case you will not be able to find out the correct result. So the cons of Naive Bayes algorithm is that it always try to find out a probability of occurrences based on the pre-occurred event. Now if that event has not happened, sunny and no, right? So there was no such condition in our data set which was given to us where there was a sunny and we have not played a golf. Every time we have played a golf, right? For no, we don't have any single data set. So in that case, I will say your algorithm is going to fail, because it is trying to consider independent probability and it is not going to give you a true result at all, because that things has not happened at all. So 0 into something is going to be a 0 in itself. But let's suppose if there was some event which has happened, in that case, yes, you will be able to find out the robust values. And this is how we can try to decide what is the probability that we are going to play a golf and what is the probability we are not going to play a golf based on the independent feature. So is this thing fine to everyone? Someone is asking me that what you have done with the denominator. See, denominator with respect to your no and with respect to your yes is going to be same, right? So maybe we can try to consider these things as a constant, because it is going to be constant, right, for all the instances that is given to you. So if it is going to be a constant for yes and no, so we can try to take maybe a proportionality constant over here, and then we can try to remove this 1 by c out of this equation. So we will calculate probability with respect to all the feature with yes and no. Yes, that is true. And let's suppose I have a multiple classes which is given to me. So class number yes, no, don't know. So with respect to all these three classes, we are going to find out. Okay, so this is how Naive Bayes equation works. It's just a manual calculation that we are trying to do based out of this table, which has been created to, which is given to us. So Akash is asking question, which one is correct? Naive Bayes assumes no feature independent of each other. Some features are independent of each other. Most of the features are independent of each other. All the features are independent of each other. All the features are independent of each other. Can you please repeat once again on a denominator part? See, just tell me one thing. So here in denominator part, so we are trying to consider probability of today. What is the probability of today? Can I say that sunny, cool, high and false, right? Sunny, cool, high and false. This is the things which is given to me. Now, if I'll try to calculate for no, again, in a denominator, I will be having the same things. So what we can do is, because we have to find out the highest probability, that's it, right? So whether we have yes, whether we have no, whether we have even a multi classes like a don't know, so everywhere we will be having denominator is equal to constant. So we can try to replace that thing with the proportionality constants, right? Generally what happens, so let's suppose if I'm writing y is proportional to your x, right? So just to remove this proportionality constant, what we do, we try to replace this c. I'm just trying to do the reverse of it, that's it. Bayes theorem works on the dependent feature, right? Independent actually. So independent of each other. no multicollinearity in between. Yes, which it should be like a independent and should depends only upon your label. So if there is a direct relationship, you will be able to find out with respect to your labels for each and every feature. So in that case, you are supposed to use a Naive Bayes equation. Now for a continuous data set, if I have to use a Naive Bayes equation, so in that case, what I can do is, so hope you all are able to remember this normal distribution, right? You all are able to remember a normal distribution from your statistics class. Now, can anyone tell me that if I have x is equals to 1, 2, 3, 8, 10, 12, 18, right? So whenever I do, like whenever I try to plot this bell curve, right? How it is going to plot? We're just giving the feature, right? One single column. So let's suppose I have given you the single column. So how it is going to find out, or how it is going to plot this bell curve? Any idea? Mean and standard deviation. Okay, is it? Because see, to plot any kind of a graph, first of all, you have to like plot all of these dots in XY coordinates, because it's a 2D graph, right? And let's suppose your X is given, but where is Y? So unless and until you don't have a Y, how you will be able to represent it into a 2D coordinates? So what happens? Okay, using histogram, using KD, you're just talking about a function name. You're not talking about how it's been done. Because my question is that, let's suppose, I believe Chris has taken your stats class, right? So he has already like taught you how to do this kind of a things. So let's suppose columns are given to me, X column is given to me, right? And then you try to do what? Pandas profiling. So what Pandas profiling does, it will try to generate a histogram and then this bell-shaped curve. This is what it will be able to generate. Now to generate any kind of this graph, we need two coordinates because it's a 2D graph, right? Only one column value for, because for every column it try to generate it, right? So only one value is given to you, only X value is given to you, right? But how it is able to plot the graph? Based on the frequency of the data versus data. No, that's incorrect. Line plot, incorrect. PCA. So think before typing something. Probability, okay. No. I think you should revise your stats concept. It's been a very long time, I believe. Right? Okay, Somesh has given me an equation, and yeah, that's a correct equation, Somesh. So basically, you must have seen, right? You must have seen this equation, f of x is equals to 1 by root of 2 pi rho square, right? Exponent of minus of x minus x mean of square divided by 2 rho square. This is an equation which is responsible for finding out a y, and this is called as normal distribution equation, and based out of that your bell-shaped curve has been calculated. So here, let's suppose 1 is given to you and this entire data set is given to you. Now let's try to look into this equation. Here you have to find out standard deviations or variances. Yes, it is possible. If data set is given to you, you will be able to find out standard deviation of this one. You will be able to find out a mean of this one, right? You will be able to find out again this one, right? So if you know this, if you know this one, if you know this one, if you know each and everything, right? If you know each and everything, for sure, you will be able to do what? You will be able to find out the y value. So for every given input, we try to find out the y value, right? And then only it will be able to generate the shape. Then we try to check, okay, fine. So it is basically a normally distributed data set or not. So this is, in other words, this same equation is called as probability of occurrence of xi when y is given to you. So even in this way, we can try to rewrite this entire equation. Probability of occurrence of x, right? So what is the probability that x will be available over here when you have a y? And this normal distribution graph again represents a same thing. For each and every independent values, it is trying to represent it inside the bell-shaped kind of a curve. So whenever, right, we have a continuous data set, right? Whenever we have a continuous data set, so in that case, we always try to utilize Gaussian naive Bayes equation. Can I say that this is the Gaussian theorem? This is coming from the Gaussian theorem of the normal distribution. Yes, Gaussian distribution is like named as a normal distribution, right? So whenever we have a continuous data set, so here we had a categorical data set. In case of a categorical data set, so we are going to use this naive Bayes equation. When we have a continuous data set, in that case, we are going to use this equation to find out probability of occurrence of X when Y has happened to a mean. We have not studied this equation in the statistics class. Okay, so because no issue. I think you can find out this one in my lecture of statistics, because whenever I take statistics class, so I do teach this one, that how this normal distribution curve has been formed, right? Because normal distribution curve is what? Whatever we are trying to draw maybe into a 2D or 3D, it's nothing but it's just a combination of points. Now, let's suppose there is something in a 2D, right? So for sure, one single dot will be represented by X and Y, right? These two coordinates. Now, X is given to me. Let's suppose I have given you X1 column, I have given you X2 column, I have given you X3 column. Now you say that X1 is normally distributed, X2 is normally distributed, X3 is not normally distributed. This is what you say, and you try to find out, and then you try to do something to normalize it, to make these things normally distributed, right? So let's suppose if 1x is given to you, like it's just a 1D data set which is given to you, how system will be able to plot a 2D graph out of this one? So there must be something which is trying to help me out to find out the second dimension of the data set. So this is the equation, 1 by root of 2 pi rho square, or you can even write in this way. So 1 by root of 2 pi outside of this row, exponent of X minus its mean, if it is a sample data set, of square divided by 2 rho square, right? So I have just taken these things outside of this one. So this is the equation, and this is called as Gaussian equation, or this is called as normal distributed equation, which always helps you out to build a normal distributed graph, or any shape of the normal distributed graph, even if it is the skewed one. So it always try to tell you. Yes, I watched this equation in your lecture. Your lecture is really good. Yeah, so I have already discussed this equation. So because whenever I teach normal distribution, so this is a core part of it, which I used to explain that how this graph is actually been formed. You talk about like a KD plot, you talk about histogram, right? You talked about normal distribution. So everywhere, so everywhere, we does that. Okay. So what is a difference between naive and linear regression? Looks like both have the similar kind of a limitation. Not at all. I think your understanding is incorrect completely. So how you are going to compare these two things? So this is a naive Bayes. Now let's try to see some sort of an implementation of a naive Bayes. And I think things will be pretty much clear to all of us in that way. Okay, so let's try to see some sort of an implementation with respect to a naive Bayes. Right, so maybe we can try to talk about a Gaussian naive Bayes. Gaussian naive Bayes has been used when we have a continuous data set, or maybe we can try to talk about a simple naive Bayes, so which has been used in terms of a categorical data set. Okay, so here if we have to build an algorithm, so maybe we have to import all those libraries. So maybe I can try to do import pandas, same old libraries import pandas as PD. We can try to import. Import numpy as np from sklearn preprocessing. Import standard scalar if it is required, and then maybe we can try to import naive Bayes. sklearn dot naive Bayes import. See, there are so many naive Bayes which is available. There is something called as Bernoulli's naive Bayes. There is something called as categorical naive Bayes. There is something called as a base naive Bayes, right? Which is nothing but probability of occurrence of A when B is already given to you. There is something called as Gaussian naive Bayes. So let's suppose if I'm working with a continuous data set, as many of you have said that try to use continuous data set. Fine, so I'll be using that Gaussian naive Bayes. So here we can try to use maybe a Gaussian naive Bayes in that particular places, and we can try to maybe train the model. Okay. Now here, what we can do is, so maybe we can try to do import. Rest of the import, if I have to do some sort of imputation or maybe training and testing a split or something like that. So maybe from sklearn dot model selection and then import import. So train and test split. Okay, so I made a mistake in line number 3. Okay, this one. No issue, it's a minor mistake. Okay. And then maybe we can try to call from sklearn dot matrices and then import maybe accuracy score, maybe import confusion matrices, maybe try to import like a ROC curve over here and here ROC curve. We can try to import over here. Maybe we can try to import matplotlib MAT. Okay, catches on. Matplotlib dot pyplot we can try to call as PLT. Okay, fine. This import is done. Line number 7, there is an issue. So from this one, okay, so this will be like a import. Fine. So these imports are done. Then maybe I think you all have a diabetes data set, right? Which is again open source data set. So read CSV. Diabetes.csv. So I think we all are aware about these data sets, right? It's a continuous data set that is given to me. And here, like we have a variety of columns. So whether variety of like a column like a age, pregnancies. So here diabetes is equals to 1 or 0, right? So you have a diabetes or you don't have a diabetes. Now, if I'll ask you to solve this problem, like classification problem. So which algorithm you should choose? So whether you should choose a subword vector machine, you should choose a decision tree, you should choose a random forest, you should choose a like a logistic regression, you should choose a k-nearest neighbor, or you should choose a naive Bayes. If I'll give you all of these many options, right? So let's try to do one thing. This is the data set which is given to you, and you know so many classification algorithm wise. So you are aware about logistics, you are aware about a decision tree, you are aware about a random forest, you are aware about a SVC or SVM, you are aware about a KNN, you are aware about a naive Bayes. Now, out of these many algorithms, if you have to choose a best one, or maybe XGBoost, because XGBoost we have not done practical, right? So maybe we can try to skip that part. So skip this that equation over here as of now in consideration. So here, if I'll try to ask you that which equation we are supposed to use to perform this operation. So what will be your best bet? Please share the data set. So I think this data set we have already used in the past. So it must be available in your system. Okay, so people are suggesting me like a logistics, people are suggesting me like a random forest, people are suggesting me a naive Bayes, right? So naive Bayes actually all features are effective individual to the output. Yes, that may be true, right? So see, we can try to think about each and every algorithm, and we can try to understand about the data set, and maybe based on that we can try to pick and choose. That is one of the way. Another way is we will try to build a classifier with all the models, and then we will test which one is giving me the stable result, right? Let's suppose my theory is very, very big, right? I'm not good with the theoretical things, let's suppose, right? I'm not good with the theoretical things. I'm not good with the interpretation things. It's fine. I'm good with the programming. What I will do is I'll try to build a stable model. I will try to do a hyperparameter tuning with all the algorithms, all the classifiers, right? And then I will try to check their stability. So whichever is giving me a best stable model, I can try to pick and choose that particular model. Can I say that? Yes. If I'm not very strong theoretically, if I'm strong theoretically, so maybe in that case, I will not be able to eliminate all the algorithm, but some of them I will be able to eliminate just by doing a comparison and looking into a data set. So now, if I'll try to look into a data set, so we have a pregnancies column, we have a glucose column, we have a blood pressure column, we have a skin thickness column, we have insulin, BMI, diabetes prediction function, age column, right? And we have an outcome. Now, if I understand a business, if I understand this diabetes cases, right? So can I say that a person will be a diabetic one, right? And yes, it is like it depends upon the independent things. It depends upon the independent symptoms that we are going, or maybe depends upon the independent values, right? So there is a very high chance that this data set, all of these features that we have is independently contributing to this outcome. Can I say that? In case of business, if I understand the business, because I will not be able to give this answer unless and until I don't understand the business part. I don't understand what is a meaning of diabetes and how diabetes happens. So let's suppose doctor told me, I have consulted with the doctor, because in this case they will be the business user, right? So I have consulted with them and they said that yes, whether you have a diabetes or you don't have a diabetes, it doesn't depend upon the combined relation, that no, you must be a pregnant one, or maybe your pregnancies must be this one, you must be having this much of glucose level, this much of blood pressure. No, if your glucose level is going very down, very high, or very low, maybe it is going to affect your final result. If your blood pressure level is going very high or very low, it may affect your final result in terms of whether you are diabetic, whether you are not a diabetic. If your skin thickness is very high or very low, so in that case it may affect. So if doctor is going to confirm, because they are the business user in this case, and they are going to confirm that, okay, so these independent features, right, is contributing in your final decision, because doctor is also trying to take a decision based on the reports, right? So they try to check your glucose report, they try to check your blood pressure report, they try to check your insulin report, they try to check your BMI ratio, they try to check your age. And can I say that based on those independent report, they try to tell you whether you are diabetic or not, and based on that they try to suggest you the medicines. Agree everyone? Forget about your machine learning. Everywhere people think that I will just try to apply the algorithm and it is going to work for me, but generally it does never happen. So business understanding is very important in all the cases, whether it's a very small case or whether it's a very a complex one, right? But business understanding always comes into a very first place. When I talk about a data set understanding, people generally think that I will do a ADA and then I have a data understanding. No, you are completely incorrect, right? So here, data understanding simply means that how you are able to understand a business. Based out of that, this data set has been produced. Then only you will be able to make a decision. Otherwise, no. So now doctor has confirmed who is my business user, right? Doctor has confirmed that no. So even in my case, so I check all those reports individually, and then there is an individual relationship between your final result, which is nothing but whether you are diabetic or whether you are not diabetic, right? And based on that, we decide. So can I say that I will be able to get a very clear understanding that maybe I should go ahead with the naive Bayes equation instead of building a generalized equation, instead of taking the generalized equation? Agree? Anush is saying have a diabetic person in my family and can correlate whatever you said. Yeah. So but this is what happens, right? So can I make a statement over here, right? So share the raw data details, sir. We have already shared these things with you, sir, so many times. It's not a new data set that we are using. It must be available in your system. Please check. Yeah. So see, so here, based on, if doctor has confirmed me that's based on this independent things, your final result is going to depend. So in that case, which algorithm I'll try to choose? Yes. So HP has pinged me a data set link. Let me ping these things to every one of you. Yeah. So can I say that in this case, right? So in this case, I will try to choose a naive Bayes that we have studied just now, right? This is the specialization of the naive Bayes, right? That it always try to consider independent features. So are you able to understand how we are selecting algorithm, which algorithm we are supposed to select? Yes. So when you try to select an algorithm, it doesn't like, it never just depends upon your like a algorithm knowledge. Suppose you are very good with the knowledge of algorithm, right? But no, that is not going to help you out to make a better decision. What is going to help you out? When you have algorithm knowledge plus you have a business understanding. When you will combine these two, then you will be able to use a algorithm. Then you build a model, right? So model building is not just about like call the data set, pass it, fit it, and then my work is done after doing train and test split, right? So it's, yeah. So whenever you are explaining these things in an interview, please try to explain in this way. Don't try to explain always in the terms of technical things, technical word, because we all understand. If you're just talking about technical words, right? So we know that you have just studied, you have not implemented, and we will be able to catch you very, very easily, right? Just within 5 minutes. Now, so here is a data set that we have, and I can just try to like pass on this data set, maybe inside my this one, name bias, right? But before that, so I'll have to do like a check. So what like how many number of zeros column we have, or how many like number of the ones column we have, and all those things we are supposed to check. So I believe we have already used this data set in our past, and we have already done this kind of a checks, right? We have already done this kind of a checks. So how many null values do we have, or how many like data set we have as an skew data set. So null value wise, I don't believe we have a null values in this data set. So data dot tscribe CRIV, and we can check. So pregnancies 760, 760, 768, 768. So we don't have any kind of a null values over here. So I think we are good to go with this one. Yeah, we do have some sort of a skewness. So you can try to remove it. I think with respect to the same data set, we have seen these kind of things, right? So you can try to check that skewness part, you can handle it. I will try to implement just a raw algorithm. Data dot drop. So I'm implementing raw algorithm. Doesn't mean that you are supposed to implement a raw algorithm. You are supposed to handle each and everything, and then you have to implement it. So data dot drop, and maybe we can try to data dot drop columns is equals to which column? Outcome column. I'm trying to build X, right? So outcome column, I can try to drop it. We don't have index column, right? Okay, we don't have, I believe, index column. And Y is equals to nothing but data dot your outcome column. Outcome column. Fine. So X and Y is done. So both of these things is like implemented and created for me. Now maybe if I want, so I can try to go ahead with the standard scalar, because there are lots of variations I can see in between this data set. So maybe I can try to call a scalar is equals to a standard scalar over here, and maybe a scalar dot fit I can try to call. Fit transform I can try to call. I can try to pass my X data set over here, and yeah. So this is like a great, we can do it. And this is my scaled data set I will be able to get. Or maybe I can write it down X underscore scale. So all the X scale data set I will be able to get over here. Now, maybe we can go ahead with the train and test split if we want, right? Train and test split, we can try to do it. So X scaled. So yeah, now many of you can say that I have introduced a data leakage, right? There is a possibility. Test underscore size is equals to 0.25. Random underscore state is equals to 30. So just try to keep it as it is, as me. So in that case, you will be able to get a same result. So X train and then x underscore test, and then y underscore train I can write, and y underscore test test I can try to write. Fine, it's done. So training testing data set is done with me. And I believe I have already done an import of Gaussian naive Bayes. Why Gaussian naive Bayes? Why not Bayes naive Bayes? Because I have a continuous data set given to me. That is the reason I'm using Gaussian naive Bayes. There are so many naive Bayeses you will be able to find out. And here is a complete list of it, right? So just not like a one. There are multiple. So naive Bayes, like just the equation will change. That's it. So here, maybe we can try to write Gaussian naive Bayes. We can try to create an instance of it. So naive underscore Bayes, we can try to create an instance of it. You can try to check out these parameters as well, right? All of these parameters you will be able to check out. Now here I can try to call naive Bayes dot fit. We can try to call over here, and we can try to pass x a train comma x y train we can try to pass, and then this algorithm has been built. Now once this algorithm has been built, maybe we can try to check what is a score of this one. So we can try to pass maybe. So guys, if we have to check the score, what we are supposed to do? So can I say that we can try to pass okay, so for model evaluation, Baba has written the complete thing. So here we can try to write y test and y train comma y test. Sorry, we have to find out the score part, right? So we can try to find out first of all prediction. Naive Bayes dot predict, and then over here x underscore test we can try to pass, and this will be the y prediction, y underscore pred, and here so y pred we can try to pass with y test, and that is the x test we have passed. Expected 2D got 1D instead. Okay, no issue. So I can try to pass 2D over here. And what is this ND? Y pred. This is 2D. By default, score should take X test and Y test, right? Yeah, by default, like X test, Y test, it should work. Okay, yeah, sorry. Sometimes what happens with your brain is like it like a start hanging, right? So yeah. So this is the accuracy that we are able to get. Now, apart from this, so you can try to even draw the confusion matrices, right? So yeah, so sometimes you will not be able to see what you're writing. This happens when you sit very long time in front of system. So here is the score, and yes, we can try to like make a better model. Even we can try to generate a better model. Maybe we can try to save it if we want. So maybe we can try to call a pickle, and then we can try to call like a pickle.dump. We can try to save it. We can try to productionize those models. One more thing we can try to do over here. We have like so many columns, right? So we can try to even light, or we can try to even call a PCA in this particular place. That is also possible, right? So we can, but I have one question for all of you. Let's suppose if I'm using a naive Bayes, am I supposed to use PCA in that case? If yes, why? If no, why? So can I say that we are not supposed? Yeah, many people are saying like a no. Why no? So can I say that if we are going to use a PCA or any dimensionality reduction technique over here, So a meaning of standard reduction technique is nothing but, so it try to take a component of all the axis and then it try to recreate a data in a different axis, right? So in that case, can I say it will not be able to retain its independent relationship with a y values. It will lose independencies in between or independent impact in between. And that is a reason. So we are not supposed to use a PCA over here. Agree, everyone? No. So Naveen is saying that this is a small data. No, that is not an answer. The answer is we are not supposed to use it because data set itself will lose our independency, right? And what is the meaning of Naive Bayes? Naive Bayes simply says that if you have a direct relationship between your feature and your label, if your feature is independent of others, and if your feature is independently going to affect your label, in that case, use Naive Bayes, right? So I think you all are able to get the answer. So I have a question. We need to find a p-value in every column for the feature selection. No, it's not like required. There might be any column which is not taking a part in the label because of the feature has an independent contribution toward the outcome. So we avoid PCA for tree-like model. No, in case of tree-like model, you are not supposed to avoid it. Naive Bayes is not a tree-like model. Naive Bayes is a completely different model, right? So in tree-like model, you can use a PCA, but not inside a Naive Bayes. You are not supposed to use a PCA at all. How to know if a column is affecting the label independently or not? I think I have already given you an answer. You have to connect with a business user, understand a business part first of all. Not just look into the data set and this numbers is not going to tell you anything, right? It's just the numbers. So you have to connect with the business users, discuss that, okay, fine. So what is the meaning of this data? How we are producing it? What is a relationship in between all of these things? So in this case, so it's just simple diabetic data set. You can try to understand, and then based on that, you can try to make a decision. Yes, okay. How we introduced our data leakage over here. So yeah, we have introduced a data leakage over here because we have called a standard scaler on top of the whole data set. And then we are doing a train and test split. So if we have used a standard scaler on whole data set, so standard scaler is nothing but it's a generalization of the whole data set. So it simply means that we are changing others by affecting the other existing data set. So here we have introduced a data leakage. So ideal approach will be, so try to take a training data set and then try to take a testing data set separately, try to do a standard scaler for this one, and then try to maybe like do a standard scaler for your testing data set, and then do these things. What is data leakage? I think I have already given an answer in today's class itself. Even when we have a test, we will do a standard scaler, right? Yes, if you have done that with the training. So for sure you have to do with the testing. Kindly help me to understand these two questions. What is the best approach if we have 50-60 missing values in the 50-60% missing values in the feature? So see, if you have missing values 50-60% in the feature, it's better not to consider that data set for training the model, right? Because this data set is an insignificant data set. What should be the best approach if we have more than 10 to 15 categories in the feature? See, best approach, even we have like a 9-10 features over here. So what is the best approach? Best approach is none, right? So best approach is understand the business, try to understand the relations first of all, right? And then try to decide what is the problem I'm trying to solve, and then try to decide the algorithm. There is no best approach in this one. So does it take care of data balance? Which one? Sorry again, but I want to know glucose is dependent on the pregnancies in the data set, sir. Glucose is dependent on the pregnancies in the data set. Just see, whenever pregnancy level is less, it's varying between 80 to 90%. How it is independent feature. Just try to check a VIF score in that way, right? So VIF will tell you clearly, very clearly that, okay, fine. So what is the dependencies in between? So I think we all have done this VIF things, right? Try to find out variance, inflation factor. Yeah. And then try to check. You will get to know easily. So maybe I can try to call this one pandas or data frame variance inflation factor X scale. So what is my X data set? So X is scaled over here. We can try to replace these things. It's scaled over here, right? And then it's like a name error is not defined. So variance increasing factor is not defined over here. So I'll have to like call VIF. Maybe I have to import this VIF. See, VIF of all of these things is like, what is the VIF values? So it's a very, very low, right? Like any other question? Initially, I was thinking XGBoost will be the best algo, but while implementation on use case, gradient boosting was working very well than XGBoost. See, like I said, like many times in your classes, that none of the algorithm is good or none of the algorithm is bad, right? Every algorithm works with a certain shape of the data set, certain relationship of the data set, right? And before even a data set, we always talk about data, right? Before even a data set, we should focus on the business problem and plus how they are producing the data set and why they are producing the data set. This is something that you are supposed to know in the very first place. Then you should like implement a machine learning, because your knowledge is like you are going to lie just as a 5% in terms of implementation of algorithm. A major part always lies on the other side, which we always ignore, right? And this is a point this kind of a points always creates a void when you go for the interview. So you are able to explain the algorithm part, but you are not able to relate those things with the actual business case, and you fail over there. So just try to understand, everything starts from the business, why they are producing the data set and how they're producing. So start always from that particular point, like I've explained in case of this particular data set, whether it's a small, whether it's a big, but this is applicable to everyone. Yeah. You explain lower and upper bound in the random forest in short. Lower and upper bound in random forest. What is this lower and upper bound? Yeah, so I think I'm done for today, right? And let me just naive Bayes, rename. And this one was clustering. And this one was PCA. Download as IPONB. Okay. So I'll just ask my team to like upload these files. And anyhow, guys, these files are already available inside your dashboard if you will check. So whatever I taught you, so everything theoretically, mathematically, picture wise, right? Everything is actually available even inside your dashboard along with the data set, right? Everything with a write-up, so that whenever you are going for the revision or whenever you are going for the interview, so you will be able to easily get it. Yes. So you're not supposed to struggle at all in terms of finding out a notes, even for a single algorithm that I have discussed in your class. Everything is available. But what I will do is, so I have my own ML masters like a, yeah. So I have my own ML masters like a directory. I'll just like ask my team to upload this ML masters directory where all these things are given. Same thing, which is already available inside your dashboard, right? I'll just ask like my team to upload these things so that you will be able to make use of it. And whenever you are going for the interview or something, revision wise, just look into this one. Plus, always try to recall. Reading out something or maybe like taking a note of something is not a solution. You will not be able to remember for a very long time. If you would like to remember something for the very long time, just recall it in your brain for 5 minutes, maybe 1 minute, 30 seconds, right? that what is the meaning of naive Bayes, in which case I'm supposed to use a naive Bayes, what is the equation of the naive Bayes, right? If I have to explain these things to someone, how I will be able to explain a naive Bayes to someone, how I will be able to explain a decision tree to someone, what is a Guinea, what is the impurity, what is the meaning of ensemble technique, what is a like a classification, what is regression, what is clustering, how DBSCAN works, how hierarchy clustering is going to work, how k-mean clustering is work, what is cell-out, what is rand score, what is a Jaccardine coefficient, right? So in this way, if you will just try to recall, so when you will recall for the very first time, maybe you will miss out something. You will go back and check that, okay, fine, so this is available, like this is the meaning of it. Then again, you will do a revision. Then again, you will do a revision. So in this way, once you will be able to repeat this process like 3 to 4 times, it's easy to remember anything for a very, very long time, believe me, right? And it takes very less amount of time to revise. So when you will start reading something, it will take time, right? But when you will try to recall something, it won't take time. So just try to like recall. Hope you have like you remember what is meaning of precision and recall, right? So just try to recall. Big data job preparation in YouTube today is live, sir. Yes, so I'm going live at 7 p.m. IST with Manas. Manas was my student, by the way. When I used to teach big data, and he has made a transition. I think 2 or 3 years back. So he is a guy from a mainframe, I believe, and he has made a transition 2 years back. He's now working into a big data. Now again, last week what happened is like he pinged me, and he said that again I'm able to make a transition, like another switch, right? And this time his package is 28 lakh that he's able to get. So in his next company. So I said that, okay, fine. So let's do one thing. Always I keep on giving this discussing these questions, that how interview happens and how this happens, that happens. So this time let's do it together. So that is the reason. So I have scheduled this event. That was the story behind it. How many years of experience? I believe 5.5 or 6, around this one. He is having experience like 6 year, you can say. Yeah, 6 year or 28 lakh. So yeah, I can show you his messages as well. So he's my like an old student from my big data batches. And yeah, so even there is a record behind. Even there is another person. Same day, I got a notification from another like a person. Her name is Ruchi, and she is joining PayPal. Again, she has secured almost a similar kind of a package, right? So she was also my student, and for her, it was like a second transition. So this is what happens once you will make a transition. Every one of you, I have seen that. This is the pattern. So once you make a transition, again you will make a transition. So this is like a message that I have received from, I'll just show you, right? Yeah, so I think my WhatsApp message is visible, right, with Manas. So भैया आपके आशीर्वाद से मेरा नया डोनेशन में हो गया 28 लाख पे. थैंक यू फॉर ऑल दैट यू हैव गिवन अ गुड करियर. आपका विद्यार्थी, कॉल उठा लेना, मेरा कब से बात नहीं हुआ है. चलिए, I don't pick a call, right? So because of my schedule. I feel sorry most of the time, but yeah. So so yeah, this happens. So it's like a very, very common thing. I have thousands of messages. I'll discuss. I'll show you sometime. Like I have so many such kind of messages, not just one. So we are like going live on my YouTube channel at 7 p.m. IST, where we'll talk about like what kind of questions people are asking, what kind of expectations people have, and all those things. This is something that we are going to discuss. हमारे बैच का इंटरव्यू प्रिपरेशन कब से है सर? So start doing it, right? I already told you. So start like prepare those. Many of you, right? Even today, see, when I have started the session, so some of you have pinged me, Subham, I believe, and Dipanjan. So they have pinged me that they are able to get a job. Again, yesterday I did a recording with 2-person testimonial recording. I have done with 2-person. One was, so I'll just like show you. I'll publish it. I'll just publish it, right, so that you will get to know. So I think that video is ready now. So yeah, they are from your batches. They are able to like make it very easily. So it's like people are able to do it. They are doing fast track, some of them, and they are like able to prepare the resume. We are available. We are helping you out in terms of preparing the resume. So don't wait for like end of the session, because we will go after the schedule. Simple. So if we have to like do something, so we will try to follow our own schedule. But if you are going in fast track, we are not stopping you, right? So we are like open to discuss your resumes, your profile, your projects, whatever you want. So just discuss. I got an offer as a full stack data science in a Petney Boas, 200% hike. Okay, that is amazing, Subham. Connect with me, Subham. I think we should discuss. Yeah. So I think we can discuss. Already connected. Okay, that's great. Yes, fourth offer. And third year BTech, should I go with live classes or fast track? If you are in third year, I think live is fine for you because you have a time, right? Devanjan Chaudhary, how do I connect with you? So just like okay, ping me on my WhatsApp number, 917. WhatsApp number. You can ping me directly, Devanjan, or a WhatsApp. Yeah, thank you. So fine, guys. I think we are done for today. So tomorrow an agenda will be. So let's suppose if I'll go to your iNeuron website, INEURON.ai, right? So here, if I'll go to full stack, this is your batch. So we are going through this one. So regression, decision, naive Bayes, ensemble is done. Boosting, implementation is pending. Stacking, implementation is done. KNN done. Damage reduction done. Clustering done. So I'll try to discuss maybe anomaly tomorrow plus XGBoost. These are the two things which I'll show you, because in anomaly, it's more like a implementation, right? So I'll be talking about anomaly. I'll talking about a boosting if time allows. This is a small topic. I'll try to wrap up. From next Saturday onwards, we are going to start our project, right? Which is very, very crucial, very, very critical for all of you, because at the end of the day, these knowledge are not going to work. This is just a base that we have created. Actual things which you are going to explain, actual things that you are going to discuss with your interviewer is a projects. The things that you are going to write in your resume, the way you are going to present these things in your resume, going to matter a lot. So from next week onwards, I'm going to start a project part. Is it fine to everyone? Yes. So that now we will just try to focus on the job side, right? So fine. Like, because nowadays there are so many opportunities which is available. Believe me, there are so many opportunities available. Even with us, there are so many opportunities. Even with our like associates, there are so many opportunities which is available, right? And we are looking for a resume. People are looking for a resume, and apart from that, many companies is having an openings nowadays. Just try to get it as much as possible and as soon as possible, right? So I have a achiever group with me. I'll again show you, right? So I have like a achiever group. In this group, as of now, I have like a 207 person, right? So I just have to like fill this group. So hope you are going to help me out in terms of filling this group. So I have to touch 259. So like this group we have created like recently, and yes, this is just like people who come and say that okay, fine. So we have done this, we have done that. So and we have made a transition, and it's their hard work. I completely believe that it's their hard work. They're really working very, very hard and to make a transition. And yeah, that's just a one-time hard work, right? So I just have to fill that particular. As of now, count is 207. I think 259 or 49 is a limit. I don't know exactly. So hope we'll be able to fill it very soon within 1 month, right? That is my target. Telegram पे शिफ्ट होना होगा. No, we'll create another WhatsApp group. That's fine for I know achievers. Who to ping for the resume preparation? Just try to drop the mail, right? So my team will respond back. And anyhow, we are doing this Monday to Friday session. So me, I was like already available on this Monday. Chris was available on this Tuesday, right? And my teammates were available on subsequent days like a Wednesday, Thursday, and Friday. So just have a discussion, simple, right? People are doing it. इंटरव्यूअर का नाम सुनते ही दिमाग ब्लैंक हो जाता है, तो क्या करें? Nothing, just try to do a preparation. Nothing you have to do, it's fine. Yeah, okay. So fine guys, see you again in my live session today at 7 p.m. IST, right, on my channel. So let's see, let's have a discussion. We can discuss even other things, right? So we can even talk about it. So let's have a discussion over there at that point of time. So 20 minutes less left plus tomorrow. So I think agenda is fixed, and next week agenda is also fixed. So from next week onwards, we are going to start a project. So we will we will start building, or we will start working on the project side as well. Yeah, that will be the agenda for next week and this week. With that, thank you so much guys, and see you again in our next class, which is going to happen tomorrow, same time, 3 p.m. IST. Thank you so much.